Please take your seats. The show is about to begin.
and gentlemen. Ladies and gentlemen, welcome to day 3. Thanks so much for having me. Let's get into it. People call me DJ Sleeper. It's my privilege to welcome VP Developer Relations. He's got the strongest forearms of any man in North America. He's everybody's favorite dancer. Please make some noise for Adam Seligman!
Hey everybody, hey, welcome. Welcome to the best day of the year. Welcome to day 3 of Next. This is it. This is my favorite part. This is the developer keynote. Excited? Got some developers in the room? All right, we're gonna have a lot of fun today. A lot of code, a lot of demos, but I thought I'd start, let's get to know each other. Sound good? So let's get a show of hands. Let's really do this. Who's a developer in the room? Raise your hand if you're a developer. All right. How about operators? We love our operators too. Get some operators in the room. How about some language stuff? Any Java developers? Yeah, I get a lot of Java developers. Node.js? A lot of Node.js. Gophers, Go. Gophers, love them some Go. Okay, let's see where you work. Who's with an enterprise, big company? Yeah. Well done. Startups? Okay, this is important. Is anyone looking for a job? This guy right here. Okay, talk to all those people around you. They're hiring. So we'll get you set up. Look, it's a great time to be a developer. Like, every industry is changing, right? Software is right in the middle of a lot of those changes. And you the developers, you're right in the heart of it. You're driving all that. And think about the tools that you use. The tools that we use are changing every day also. Open source has been just a huge part of that transformation. Think about it. When's the last time you actually set up a server, right? That's an API call now. How about configured an operating system image? You don't do that, right? That's all containers. It's all just a library of container images now. How about set up a whole fleet? Do you set up a whole fleet, or do you terraform it, right? That's the way it works now. So the other thing that I think is a really interesting change is the very role of a developer is changing. You don't just write code. You're working with big data, you're working with event streams and IoT data. You're starting to do data science and machine learning. Who's written their first machine learning app so far? Yeah, it's just emerging. It's super exciting to help you all go on this journey together. You're getting to know your users, you're doing user experience, you're managing products, not just projects. And ultimately, you're working as a team to ship great experiences out to users and customers. And I think it's a pretty amazing change. Now, cloud is enabling all this, right? We're all sort of on this journey to evolve together to this new world. We all have access to this amazing technology. You know, you can just get it as a service. Everything is available as a service. So I'm pretty sure the next 5 years are going to be even more exciting than the last 5 years. To tell that story, we wanted to talk to some community members, get some voices from our community. Any community members here in the room from the Google developer communities out around the world? Right on. Okay, we made a little video to show you some of their stories and some of the things they're working on. So with that, I want to roll a little video for you.
Funny enough, we started with a simple conversation. So imagine it's election day, 30, 40 million people showing up to vote. What our software does is allow them register these people, check for duplicates, or if there are any signs of fraud.
Can we have a loyalty program where an average person can earn points every time they shop for groceries, and this currency effectively becomes a second source of wealth to pay for everything from your electricity bill to school fees and doctor's bills.
2 of my cousin sisters suffer from breast cancer, and I ended up losing them. That's when I thought, we need to do something with technology to build a new way of doing breast cancer screening.
In my graduate school, I was one of 2 women in a class of 45. And it kind of got me thinking that this is not what it's supposed to be.
We have this patient called Maria. She's 6 years old, and she was having these daily seizures. She lived in a remote area in Brazil where there's no specialist, and no one in the city could help her.
I'm a developer during the day, but then during the evening I wear my cape and I do Google stuff.
One of the things that most amazing is being on Google Cloud has enabled us to be online and available 100% of the time with automated health checks, security checks, and logs monitoring. I use tools like Stackdriver to keep me on top of all of that.
Google and the Android platform have become kind of a backbone of our entire product ecosystem, where we could actually build this loyalty program powered by mobile phones.
We use deep learning and the technology stack called TensorFlow to interpret thermography, which basically measures the temperature on the chest and then figures out if there is any abnormal tissue activity. And this can be 5 to 8 years before a lump is formed or felt.
We're actually helping people to get access to doctors that they couldn't have without the stack. For example, this case with Maria, with Google Cloud, we connect to the clinic device, measure Maria brainwaves, send to the best child neurologist in the country, 3,000 kilometers away in São Paulo, and she found a cure for Maria. And this was awesome.
I run the Google Developer Group Vancouver chapter. I see girls from high school, they actually show up at our meetups. They know nothing about the product, and after like 1 hour or 2 hours of time, they can build something from scratch.
I'm one of the co-organizers of GTG Cloud London. We are the most active GTG cloud community in the world, and I love how you can achieve all these dreams and passions and ideas you have using the Google Cloud platform.
Whatever you do in life, try to solve a meaningful problem.
More than ever, people are asking for purpose on the work that they do.
You're not just building product, you're building product that can change people's lives.
My hope is that we will excel in technology. Women will get their seats at the table.
I feel that Google just empowered me.
From that moment, it's been love. That's pure love.
So cool. Thank you. Thank you, Amanda and Femi and all the community members. So great to hear your stories. So look, we're going to kick off today. We're going to have a great day. But I really wanted to start with a promise to you. A promise that Google is going to really do 3 things. The first is continue to deliver amazing innovation. Things like AutoML and TPUs, Silicon for TensorFlow at massive scale. The second thing we're going to do is we're committed to open source and an open cloud. You know, Google's got about 20 years of experience doing open source and being part of the open source community under our belts, and we're looking forward to doing the next 20 years with you. And then the third thing is that community theme, and we wanted to really launch that at this conference. We believe in being part of the developer community. We are engineers at Google. We sit all over the world with all of you, and we want to continue to be really connected with you as we figure out this next generation of technology. So, for the rest of the morning, we have one simple rule, and that is show, don't tell. We got a lot of great code. It's going to be a lot of fun. Let's get started, yeah? Right on. I want to introduce a great executive at Google, a vice president of engineering. Melody McFessel is going to talk to you about tools. Thanks.
Thanks so much, Adam. I'm so happy to be here today. My name's Melody McFessel, and I'm passionate about developers because I am one. And I also worked for many years in operations where I carried a pager. And I became very familiar with the phrase, "It works well on my machine." So I lead developer and operator tools at Google. This includes Google engineers, Chrome and open source developers, Android developers, and developers using Google's cloud platform. Now, each one of us probably has a different definition of DevOps. At Google, our understanding is that DevOps includes 2 things: end-to-end automated tooling, from source to build and test, to releasing with integrated observability, and the culture that supports and enables developers. DevOps is near and dear to my heart, because it's about automating away the toil while empowering the humans. Makes us productive and maybe just a little bit happy. So how many humans in the room today? Yeah, I hope so. Well, humans develop software and operate services. And at Google, we've spent a significant effort understanding productivity. Different developers need different levels of insight and care. And as developers, we want to choose the best DevOps tools to get our work done. But that choice can be hard sometimes. Imagine being a new developer and having to pick your language or framework that you need to use, or where to deploy your app, VM, Kubernetes, or which cloud platform to use. Well, that one should be easy, right? It's Google Cloud Platform. That's why we're here. And with so many choices at every stage, selecting the right DevOps tools can be overwhelming and waste our time. At Google, our goal is to make these DevOps tooling decisions easier for you. That way you can go back to doing what you love, writing code and bringing your idea to life quickly. But moving fast shouldn't come at the expense of security or stability, because without that, any speed improvements are useless. Industry research shows that high-performing DevOps teams achieve both faster releases and better stability. They deploy 46 times more frequently than their low-performing peers. And their production deployments are 7 times less likely to result in a degraded service. So think about that. You get faster releases with better stability. And what explains this behavior? Well, it comes back to this combination of end-to-end tooling and the DevOps culture. At Google, we've embraced and adopted DevOps cultural principles. First, use data to guide your decisions. Dig into the code, look at logs, look at traces to understand what's going on. Have a shared fate and collaboration between the humans, the developers and operators, because we know we're more powerful when we work together. Choose transparency over secrecy and siloing. Everyone sees the same data and information by integrating observability into your apps. And finally, embrace blameless postmortems to encourage continuous improvement within your teams. We have to accept and learn from our failure. I mean, this is software development, right? We're going to have bugs. So all of this is super easy to say, but when you live it, it's magic. This is how we build trust between developers and operators. We have to trust each other to make it happen for our users. So I want to show you today end-to-end DevOps tooling to help you build, deploy, and monitor your apps quickly and safely. Our DevOps tools consist of cloud source repositories, a single place to store, manage, and track your code. Cloud Build, a fully managed, continuous integration and delivery platform that lets you build and test your applications in the cloud at any scale. And Stackdriver, management tools for developers and operators. So let's walk through a day in the life of a software developer and operator. We're going to build an end-to-end automated pipeline using GCP DevOps tools with well-known open source tools like GitHub and Spinnaker. We're going to go from finding a problem in Stackdriver to using code search functionality in cloud source repositories to find the code. We're going to fix the code. We're going to commit the change to GitHub. We're going to kick off a build using Cloud Build. And then we're going to deploy to GKE using Spinnaker. And we're going to do all that in just 10 minutes. Morgan.
Melody.
Awesome to see you.
Great to see you here. Hello, everybody.
All right. So let's get started. So this is Hipster Shop. You may remember it from Tuesday's keynote. We're going to purchase an item.
And it is a lot slower than it was on Tuesday.
Yeah, I think its popularity increased over the last 2 days. So we're going to start our investigation looking at Stackdriver Trace, which is part of our APM suite. Our APM suite lets you do production debugging, profiling, and tracing on applications running anywhere. And with Google-led projects like OpenCensus, we're making it incredibly easy to extract telemetry from your applications, whatever tools you decide to use. So after looking at some traces, we see a couple of things. First, for a single customer request, we see many child requests. So we're just going to batch those up. It's going to make it more efficient. But the second thing that we notice here is that the requests to the catalog service are incredibly, whoa, very slow.
This one's about 2.6 seconds, just for one of them.
Okay, well, we're going to have to dig in on this. So we're going to go from Stackdriver Trace to Stackdriver Profiler, which profiles applications continually with no appreciable overhead. We've been using Profiler at Google for many years, and now our customers get to use the same functionality. So this icicle graph, it shows you the resources consumed by the function on the horizontal axis and the call hierarchy on the vertical axis. So because things are slow, we're going to go check out CPU time here. And what we can see looking at Profiler is that there's a really slow gRPC getProduct method, which is spending all of its time waiting on this function, parse catalog. And I think it's taking, what is it now? 92%?
Yeah, it's bad.
That's bad.
Yeah.
That's very bad. So let's go look at the code for parse catalog. So this application code is actually hosted on GitHub, and it's continuously mirrored to cloud source repositories, where you can use functionality like powerful code search and indexing. So we're going to come here to cloud source repositories. We're going to search for that function we saw in Profiler. And there it is.
Real quick.
So let's take a look at the blame layer. Wait, Morgan? Morgan?
You told me to slow it down.
He's responsible for this one. So we're going to hop to GitHub and check out that there's a pull request that's been created that fixes these performance issues. And it's from Morgan.
Yep. Got to fix my own bugs.
Amazing. So I'm going to approve the pull request from Morgan. And this is going to automatically trigger a cloud build run, which you can see in the cloud build UI. All right. There it is. So Zendesk, Lyft, and over 1,000 customers use Cloud Build daily to ship new functionality. So as a reminder, we're doing this all live. The build's going to take a couple minutes, so let's cross our fingers on this one. At Google, we create over 4 million builds in the cloud every day because it's flexible, it's secure, and it scales. But right now, let's go back and look at the pull request that we just approved. We can see that Cloud Build also ran a test build when the pull request was created. And we did this because we wanted to make sure that the pull request wasn't broken. Now, all of this is being done through our new Cloud Build GitHub partnership, which we are excited to announce today. With this partnership, developers are able to use Cloud Build CI capabilities to validate changes, run tests, and get results right within the GitHub UI in a frictionless way. So it's super easy to get started. As long as you have a GitHub repo with a Docker file in the root directory, GitHub will automatically suggest Cloud Build and its CI capabilities. You can see it here. And you can get started running builds in just seconds. Cloud Build makes high-velocity software development safe, easy, and secure. It really unleashes your team's productivity. So let's check the build. It's almost done.
Almost done.
Hopefully. This is where we need the DJ to be playing a little bit of music.
One of the nice things about Cloud Build is it shows you the logs right in the console, which you can see here. And so it's finishing the final step right now. It's pushing it up to GCR, and now we're done.
All right. Live demo, folks. So all the tests passed. We're good to go. But I keep mentioning security. So I want to show you, Cloud Build will actually do security scanning for you. So we're going to kick off a scan, and actually it's so fast, we didn't find any vulnerabilities, so we're good to deploy that. And Morgan, if you can show an example of maybe a past project with some.
Yeah.
So you can see here, we wouldn't deploy these images because we need to fix the issues first. All right, so we've done our build, we've done our tests, we've checked for vulnerabilities. Cloud Build is now going to trigger a Spinnaker pipeline to deploy the image. Google has been a core contributor to the Spinnaker open source project. This was created to make multi-cloud deployments safe, fast, and secure. So today we're going to see automated canary analysis, which reduces the risk associated with deploying to production. So while we're performing the automated canary analysis, we're going to automatically promote things because we don't have a lot of time today. But what you're going to see, this is an actual pipeline that's running, and it has 3 stages. In the first stage, the canary build is pushed to a single instance of the app, and some traffic is routed to it. In the second phase, we would normally check things like metrics to see how it's developing, but we've kind of automatically pushed this forward because it'd take about 30 minutes for us to do this task. And in the third stage, the build will promote the canary to all the remaining production instances. And as you can see, the different stages, the color turns from blue to green as it progresses through the canary analysis. So I'm sure everyone here is familiar with automated canary analysis itself, but quite often when we do this, it's manual and ad hoc, and therefore it's prone to our own human bias and error. With Spinnaker, you can now automatically promote or fail the canary, minimizing your deployment risk, while continuing to release as fast as you possibly can. So assuming that these changes look good, Spinnaker will automatically push or roll back the canary. Using Spinnaker, Waze was able to create over 1,000 production delivery pipelines while reducing their deployment errors by almost 95%. That's pretty amazing. So the deployment is almost done, but we want to show you one last thing, which is the Stackdriver Profiler has this really great comparison feature, which lets you look at CPU consumption patterns that change within versions. And so you can see we're running this on some older data, but you can see how slow functions will shrink. These are highlighted in blue. So let's go back to the Spinnaker pipeline.
Just a couple seconds left.
Couple seconds left.
So I can show you on this profiler view the parse catalog function that was taking up so much CPU time before. It's now effectively fallen to 0, which is probably where it should be. So this comparison view lets us validate that on that second build that we built, even though this is from older data, that we fixed that problem. So let's go take a look at Spinnaker again. It's still going.
Awesome.
A couple more seconds.
Couple more seconds.
Now this is rolling out on Spinnaker to, I think, 5 or 6 different instances on Kubernetes. So like Melody mentioned, we took a canary build. So we took over one of those instances with the test build, ran some checks on it. For the purpose of this demo, we just made that always pass. Once that passes, then we go and deploy that to the remaining instances within Kubernetes.
Oh, it's green.
It's green.
Live demo, folks. My fingers were crossed behind my back. So let's go back to the hipster shop, surf around.
It's a lot faster.
A lot faster. All right, there we go. End-to-end automated tooling using GCP DevOps. Thanks a lot, Morgan.
Thank you.
Awesome job.
Thank you, everybody.
All right, well, we want to continue to collaborate on open source tools like Bazel and Go, and we want to work closely together within the ecosystem. But collaborating in the ecosystem means being open and working well with the tools and technologies that you already use today. So I would just want to take a second and highlight 2 ways that we're committed to being the open cloud. Terraform from HashiCorp is a leading technology in writing and creating infrastructure as code. We're committed to making first-class support for products like Terraform, and we have a dedicated team within Google to support our partners like HashiCorp. Our friends at GitLab have built a complete open-source DevOps stack. We started working with them a couple months ago to integrate with GKE, and at Next, we're showing how you can use Cloud Build to scale your GitLab builds. We're also helping to move GitLab.com to run on top of GCP. I believe that through these collaborations within the ecosystem, we are going to make it better together. So today, you saw Stackdriver APM tools, including Trace and Profiler. Profiler just went to beta on GCP, and our alpha participants have said they were saving about 10% of their compute bill with less than an hour of work. Snap was able to achieve some pretty incredible optimizations. You saw fast code search, using cloud source repositories. And you saw Cloud Build, the launch of Cloud Build, automatically run builds and tests in the cloud at any scale. That included vulnerability scanning. Shopify uses this feature to scan over 6,000 builds a day and 330,000 images in the registry every day. And it's amazing to think about that scale. Finally, you saw Spinnaker help with deployments and have awesome features like automated canary analysis. Businesses like HSBC and Snap and eBay and PayPal use our DevOps tools every day to ship new features and functionality. We hope you will try out these GCP tools today. Google spent the last 2 decades iterating on developer and operator tools. Every developer and operator deserves this level of automation, speed, and scale. We're even more excited about the things that we're working on that you're going to see in the coming year. Let's help you focus on the things that you love, bringing your ideas to life. So next up, Kelsey Hightower is going to do a great demo and talk through some of the tools that I mentioned today. Thanks so much for your time, and have an awesome conference.
Oh, wow, this is like an alternative Tron universe. I've been using Kubernetes so long, I finally ended up in a container. All right, so all week we've been learning about all these new technologies, Istio, Envoy, Kubernetes. Like, how do you put all these things together? So I work at Google, and when I think about Google Cloud, I think about things all the way from my laptop with my Chromebook to the Maps API and tools like Dialogflow. So what I want to do is walk through some of these things and how I think about putting these things together. Now, I also want to show you some of the tricks that I do. So I'm going to start from the bottom and build a weather application from zero, starting with the database, all the way up to the endpoint. Now, we only have about 15 minutes, so we're going to see if we can get this all done in time. So the first thing we're going to do is kind of start with this example. So here's a terminal. Everyone like terminals. Is that cool? Someone's like, where's my GUI? We'll get there. All right, so what I want to do is maybe start with a few weather locations. So these are all of our regions in the US, our newest region being Los Angeles, California. And the goal is I want to take these names and get weather data. Now, here's the problem. I can't just give these names to the weather service. I actually have to give them geo-coordinates, okay? Now, I have a couple of options here. I can actually use the Maps API. So the Google Cloud Maps platform does provide a Places API that I can trade those names in and get back some coordinates or something close. And then once I have those, I can actually send those to the weather.gov and actually get back coordinates. But here's the thing. I don't have a lot of time to write all of this code. Now, once you become a senior engineer, I'm going to teach you a couple of tricks. Now, this is what all senior engineers do. You guys ready for the first pro tip? Now, you got to write some code. Now, this is what we do. You do this. If you haven't heard of Stack Overflow, you have no clue what's going on. All right, so let's do this. Google Maps platform. Like, this is high-quality code that you can find on this thing, man. Trust me. And we'll do weather. And then, OK, let's go here. All right, how do we do this? Oh, code. This looks legit. All right. I'm not sure who this Terrence Ryan guy is, but, you know. Now, this is the internet, so what you got to do is you got to scan for those security vulnerabilities. All right, you got to make sure this stuff is legit. Hold on, let's make sure we can grab this. Let's see what we're going to do here. So let's grab this code. Come on, I don't care about cookies. It's the internet. How dangerous could it be? Where's my copy and paste? Like, why are they trying to sell me stuff? I'm trying to get my job done. Oh, come on. Like, the hardest part of this, all right, look at this, ads. All right, we should be in business now. All right, so let's grab this. So what you want to do is you want to scan for security vulnerabilities as you go through this. That looks legit. Talking to a database, sure, why not? Cool. Let's just grab that. So here's the thing. Oh, I didn't grab it? Golly, I should be fired. This is why we use GIST. All right, copy. So one thing is, good programmers copy. Great programmers paste. All right, so we got our code. Now, the next thing we need to do is set up a database. Now, I am the world's most average DBA. So for me, I'm going to use a hosted database service, and I like to keep it open source. So my favorite database is Postgres. And what I'm going to do here, listen, if you're a developer and you need to set up the database, there is no shame in clicking the button. Click, database. Bam, like a pro, okay? You got to own it. So I got this database set up, and I created a user. I actually do not know how to create a user, so I usually click this button because I can't have to look it up all the time. So once I have the user created, I have a little env file so I can use natural tools. So the thing I like about this, I can use my existing tools to do my job. So the first thing we're going to do here is we're just going to get the environment variables for my connection string in my environment, and then we're going to see if we can connect to the actual database, and I can. Let's make sure we don't have any tables set up, so we're starting from scratch. Now, the next thing I need to do is actually set up the database schema, all right? So there's some, SQL is dope, by the way. If you don't know SQL, you should learn it. Okay, so PSQL, and then we're gonna just run this create database command. Uh-oh, we need to get our credentials. So pg.env, and then let's do this. And then, come on, we got a database schema. And let's make sure we don't have any data in there. All right, we're starting from scratch. So the next thing we're going to do is we're going to change into that directory where we've downloaded that production-ready code from the internet. And what we're going to do is we're going to give it credentials, okay? So this should be cool, legit. This guy is a nice guy, I'm pretty sure. So I'm going to put those credentials in my environment. And then what we want to do now is just do something local. So when I build code, I like to test locally. I do not develop in a container. I test things on my local machine. So here what I want to do is do a quick build. And I'm using the new Vigo stuff so I can actually do development work without using a Go path. So for me, I'm writing everything in Golang. And then what I'm going to do is just build the application. Ooh, and it compiles. That's legit. So let's try it. Let's see what we can do. So remember, the goal is we're going to take locations, and we want to trade them for geo coordinates so we can then talk to the weather service. So let's try that now. So we'll do weather data. Oh, look like it's working. All right, so look at this is like science, geo coordinates, okay? All right, and then we're getting the weather data. So if everything is legit, we should be able to do a query, and we have the weather data in our database. All right, so we're in business. All right, now that we got our weather data, we need somewhere to actually run our code. And also, if you have the idea of running this command from your laptop in production every day, that's not how you do it. You might want to run this code in a cluster somewhere. So we need some infrastructure. So the next thing you do is we need a Kubernetes cluster. There's no other place better to run your code than Kubernetes. Marketing, I've done my job. All right, so, so here's a Kubernetes cluster, but there's something interesting here. So there's a couple of tricks that I like to do. Here's my Kubernetes cluster, and one thing you can do that's really nice in GCP, you can actually have multiple node pools. So this is the 1.10.5 cluster. I have 13 nodes here, but I actually have those nodes split between 2 different node pools. Now, the reason why I'm doing this is I'm using the first general pool for my web apps, my batch jobs, long-running services. But this other node pool, I'm a big fan of Envoy. So you've been hearing a lot about Istio, but underneath Istio, there's this nice reverse proxy called Envoy. And Envoy, if you can think about it, is like a cloud-native replacement for Nginx or HA proxy. It has all the things that I need to do things like rate limiting and timeouts and retries. But I like to actually run Envoy as my edge load balancer, even in GCP. It's the same load balancer I run on my laptop, so I want some parity. So what I'm doing is I'm actually running each of my Envoy instances across these 3 nodes using what we call a daemon set. And then the last thing I do to set up my infrastructure, I create a load balancer that points to just those 3 machines. So if you think about it, I have a network appliance running inside of my cluster. No extra hops, no IP tables, straight to Envoy, then directly to my apps. So with the infrastructure in place, we can start to think about deploying our code. So let's go back to the command line really quickly. So the next thing I want to do is I don't want to execute this from my machine. So here's a cron job. Every 5 minutes, it's going to kick that code off for me automatically. So my goal is just to push this cron job up. But remember, the price of admission to Kubernetes is a container image. Here's my second trick that I like to do. I have this saying, don't ship build environments, ship artifacts. So when I build my containers, I actually just build my binaries locally, upload the artifact, and only have Docker package it in an image with the Scratch-based image, right? So my images roughly are about 7 megs, and then watch how fast the builds are if I do it this way. So the first thing I'm going to do is build that application locally, take that binary, push it up to Google Cloud Build, and Cloud Builder is going to do all the work for me. You'll notice another thing here. I don't have Docker installed on my machine. I can just push my builds there and get all of my images. So in just a few seconds, we'll have a container image, we're ready to go, and then we can actually use that cron job, and Kubernetes will keep it running. So kubectl apply-f cron.yaml. All right, so you'll notice there will be no pods created until we hit that 5-minute mark, but we'll start watching just to see when things come up. So in about 5 minutes, you'll see the cron job kick off, and Kubernetes will keep a few of them around just in case I need to troubleshoot. All right, so the next thing we're going to do is, we're going to move a little bit faster now, is I need to put an API in front of this. So what I'm going to do here is say kubectl apply-f, and I have this weather API service. And then what I'm going to do here is just deploy that. And that's going to be a little bit faster because I want it right now. I already have the image on the container registry. It's going to pull it into the cluster, and it's going to start running. Now, here's the next cool thing that you can do in GKE. We've done a lot of work to make pods first-class citizens inside of Google Cloud. So you'll notice here, every pod in Kubernetes gets its own IP address. Now, the one thing that we do is we make those IPs native using a technology we call IP aliases. And what IP aliases does, it takes all of those container IPs and make them first-class in my VPC. So my development box is a VM inside of my VPC. So what I should be able to do is actually, without any port forwarding or extra hops, I should be able to make a call to my API service using the container IP. And look at that, directly talking to the container using a very natural development flow where I can work on another app while talking to apps inside of the cluster. That's pretty dope if you didn't think so. All right, so we're moving along here. The next thing we want to do is get a web front end. Again, you kind of establish some patterns here. Build a container, push it up, and describe to Kubernetes what you want to do. So here we'll build our weather front end, and then we'll do this deployment. Now here's where things get a little bit interesting. We're not going to run 1 copy. We're going to let Kubernetes run 3 copies across that cluster for us. Now, once all of this is running, I have Envoy in a pre-configured IP and a DNS address that's pointing to this particular backend. So what I'm going to do now is pull this up, and we should be able to hit the weather backend. Oh, things are looking good. Let's see. All right. Everything seems to be working. Now, here's the thing. I've been the solo developer this whole time. I know the front end talks to the API server, and the API server talks to the database, but what happens is someone else on your team needs to check things out. The nice thing is I've been using OpenCensus. So again, I don't actually have a service mesh, but you can adopt all these technologies a la carte. So if you want to add tracing to your application, you can bring in tools like the OpenCensus library that allows you to decorate your function calls or calls between apps and send that data to tools like Zipkin or Jaeger. In my case, I'm using Google Cloud, so we're going to send it to Stackdriver Trace. I'm going to pop over here to the tracing console, and then we're going to find one of those recent traces. So we can see one that just came in roughly around now, and we'll click on it. And you can actually see the end-to-end. Traffic comes into the front end, the API, and then the API returns, but not before talking to the database. Now, here's the nice thing. If you trace this inside of your code base, and I click Show Events, I can come down here and see the exact SQL query that's being executed at that particular hop. Now, that gives you the ability to actually see what's going on and give people a lot more insight without checking out the code. All right, so we got all the patterns in place. Infrastructure, tracing, and now we need to think about something new. Now, we only have about 5 minutes left, so we're going to have to simulate this. It's not when your boss shows up and it's like, hey, we need some new functionality. Can you get it done by Friday? All right, so the task is on. So we have this infrastructure. We got this nice pattern set up. And what we want to do now is start to think about something cool we can add in. We got a web front end, but that's like so 2017. You got to have a voice integration with your app if you want to be cool. If you can't talk to your application, you're probably doing it wrong, okay? So what we want to do is think about a tool called Dialogflow. You're not going to build your own natural language processing system from scratch. Some of you are probably trying. There's a better way. So we're going to use Dialogflow. So again, let's walk through the pattern really quickly. We're going to write the application, and then we're going to build it and push it up. Now remember, the container image is just the price of admission, so we'll build this up. Now here's the other thing. You won't be the sole developer working on this application forever. Maybe there's someone else on the team that wants to contribute, and maybe they have no interest in writing YAML files or using Kubernetes from the command line. We've done a lot of work to make sure that Kubernetes works well from the UI. So we'll come over here, we'll go to the Kubernetes console, and we can click on workloads. Now notice here, all the things I did on the command line are reflected in the GKE console. Now, if I have a new person on the team that's not quite familiar with Kubernetes, this could be their workflow. We'll click deploy, and we've done something special here. We've integrated deeply with GCP, including the Google Container Registry. So if I click on this, I can drop down and find that image that I just created. It finds all the right tags, hit select, and then it fills out everything I need underneath. Let's give this a name. We'll call it the Weather Assistant. We have the right labels, and if I have multiple clusters, I can choose where it should deploy. Now, if you want to see what's going on underneath the hood, you can actually display that sweet, sweet YAML that you love so much. And then we also give you an autoscaler to make sure you can respond to traffic changes. And we'll hit deploy. So that's going to do all the heavy lifting for me right through the UI, and just like that, it should be deployed. We'll switch over here, and we can see the Weather Assistant is now ready serving traffic. Now, the next thing we're going to do is make sure that we're ready by checking the health check. So here's the DNS name that I've assigned to this particular app. We'll hit it. We see everything is up working, and we can also see all my traffic is flowing through Envoy. I should be in good shape. All right, so we only have a few minutes left. Let's see if we can pull this last piece off. So I'm going to log into the Dialogflow console. This is also part of the Google Cloud Platform. So Dialogflow allows you to design these voice integrations with your application. So we'll come here. There's a couple things we need to do. First, we need to make sure that our users have a good time with our application. So what we're going to do is we're going to define all this verified inputs and create a few synonyms just in case they want to say things like Los Angeles or Los Angeles, California, USA to talk to the weather app. The next thing we're going to do is describe their intent. What does our user want to do? So here we want to have them check the temperature. Now there's no way I'm going to define everything or every phrase our users would do. So here, what I'm going to do is give Dialogflow a few training phrases, and notice how it's automatically pulling out those regions that match the entities that I described before. So we're ready to go. Now I want to send this to our webhook that we just got deployed. So we'll come here, we have a couple more steps. We'll go to fulfillment, and in fulfillment, you'll see that I'm just putting in that same URL that I had earlier that's pointing to my Kubernetes stack. All right? You have all kinds of integrations that you can do, but this time we just want to do the Google Assistant. Now, this whole time I've been using my Pixelbook to do this demo, and this is something that I also think a part of the end-to-end experience at Google. So we want to test out this. Now, I could use the simulator, or I can actually come down here and use my laptop. Now, to prove that this is real, we're going to look at the logs for the assistant to make sure Kelsey isn't cheating. All right, so kubectl logs. We'll give it that container name, and we can just stream the logs here. So we can see it's listening, but there's nothing there yet. So if I hit the assistant button on my Pixelbook, we should be able to talk to this thing. Yeah, whatever. All right, talk to the local weather service.
Sure, here's the test version of local weather.
Hello, Kelsey.
Hello.
Looks like you have a pretty large crowd here. I hope the demo gods are on your side.
I hope so too. All right, so let's give this a go. What's the current temperature in Los Angeles, California?
The current temperature in Los Angeles, California, USA is 82 degrees Fahrenheit.
Thank you.
Okay, I gotta admit, that was pretty dope.
And with that, you kind of saw the end-to-end Google experience, starting with my laptop all the way to the data model. I can use open source tools like Cloud SQL, Postgres. Then I can actually use the industry standard Kubernetes backed by Kubernetes or GKE. Then I have my choice of load balancers, so I can use familiar tools like Envoy or Nginx. And then I can use things like Open Census to add some visibility to my application and visualize all of that in Stack Driver Trace. And then I can move on to try new ideas, like adding voice integration to my application, all within the Google Cloud Platform. And with that, I'd like to introduce our next speaker, Aja, who's going to come out and talk more about languages. Thank you.
Hi, I'm Aja, and I lead our programming languages efforts on the Google Cloud Developer Advocacy Team. I like working in developer relations at Google because this job lets engineers, like myself, spend our time helping people build cool things and giving back to our tech communities. My community has given me a lot over the years, and I'm really grateful that I get this chance to give back. And I work on languages because I'm kind of a giant language nerd. I'd love to talk to you about all the languages I enjoy using, but they only gave me time to talk to you about 2 of them today. So the first language we're going to talk about is Go. Go is growing so much right now. There are an estimated 1 million Gophers worldwide. But more practically, when I go to my local DevOps meetup, Go is the language we talk about the most. Folks are using it for lots of stuff, like building microservices and improving their operations. And so I'm like, hey guys, what's with the Go? And they give me lots of reasons they like it. First off, it's the languages of the containers world. Almost everything Kelsey just showed was written in Go, including Docker and Kubernetes. And Go is great for systems-level programming because it's fast, and it was built from the ground up with concurrency support. For those coming from languages where concurrency was kind of tacked on later, having concurrency as a first-class concept is really delightful. And folks also like the Go is developer-friendly. There are very few keywords, and it uses familiar syntax. And Gophers rave about how easy it is to write, how it has the speed of a compiled language, and all the benefits of static typing. And all of that leads to faster performance, reduced QA time, and fewer errors in production. But personally, my favorite thing about Go is the welcoming and supportive community of passionate Gophers throughout the world. So today, I want to talk about the new Go Cloud project from Google. This library provides Gophers with cloud-agnostic abstractions for services like relational data stores, runtime configs, and blob storage. So that's a bunch of words, but let's say you have an application that uses Google Cloud Storage and storage on some other provider. Currently, you have to have 2 different branches in your code, 1 for each provider. You have to remember that maybe one provider uses the method list bucket contents to see what's in a bucket, and the other uses something, I don't know, maybe describe bucket. And it's doing the same thing, but I don't want to have to keep all that in my head. I am lazy. And the Go Cloud project helps with this by providing one set of objects and methods that work with multiple cloud providers. You don't have to learn an API for each provider. You can use one method, and the Go Cloud project takes care of translating it to the right method for that cloud, or maybe even multiple methods. And the return data is consistent between clouds, so you don't have to worry about doing all sorts of cloud-specific type checking. The big thing, though, is that with the Go Cloud project, your application code doesn't need to be aware of what backend you're using, or even if you're using multiple clouds. The API it provides allows you to set your application code from the configuration needed to connect to the cloud, so you can focus on the fun stuff, like adding new features. Eno from the advocacy team is with us today, and he's going to demonstrate the Go Cloud project. So Eno has an application that uploads a photo to cloud storage on either GCP or AWS. And of course, we're going to upload a picture of a gopher. So here's the application code that runs that. And you can see that in each method, we have a top-level conditional for choosing between the 2 clouds we have to support. And under each branch, the code is similar, but it's not entirely the same. Each cloud is initialized a little differently, and it provides objects with different methods for handling the results you get back from storage. And I've written code like this, but I'm not particularly proud of it because it's really gross. And here's the thing. We can do a lot better. So here's a version of the code that uses the Go Cloud project. The first thing you're going to see is that that top-level conditional is gone. What we've done is we've separated the application logic from the storage configuration. And to make it really clear, here's the diff between the two versions. Adam promised you all a diff. Here's the diff. You can see that there's a lot less code in the version that uses the Go Cloud library. And, even better, the code that uses the library has a better design because we've separated the two concerns. Better engineering practices lead to more maintainable code. Thank you, Eno. If you've ever had to support multiple clouds in a single application, you know that using a library like the Go Cloud project is a much easier way to do things, and it encourages good engineering practice. But library authors can also build on top of the Go Cloud project to ensure that folks on any provider can use their library. Our hope is that this project will foster an ecosystem of libraries built with multi-cloud portability in mind. The Go Cloud project is, of course, open source, currently supports AWS and GCP, but more clouds are coming soon. And of course, contributions welcome. So the second language I want to talk about today is JavaScript. JavaScript was the most popular language on GitHub last year. There were so many more JavaScript commits as there were for any other language. It's really remarkable. And I know I've written a bunch of JavaScript in my career, and I'm assuming most of you have as well. Google has been a champion of the JavaScript language for a really long time. Some of Google's JavaScript projects include Angular, AMP, Polymer, and the V8 engine that's at the heart of Node.js. And JavaScript is one of those fantastic languages that you can use just about anywhere for just about anything. If you had told me in 1995 that I would be writing server-side JavaScript, I wouldn't have believed you. But the async features of something like Node.js help you build fast, scalable web application backends. And Node.js is also the default language for functions as a service. But it can be used for non-web applications too, like robotics. And of course, JavaScript is as popular as ever for building rich client-side interactive experiences. So if you go out and learn JavaScript, there really isn't much you can't do. The community has been asking for Node.js on App Engine Standard, and we're happy to say that it's in beta. Node 8 can be used just like your other App Engine language, and you can use most of your favorite NPM modules. And if you don't know, App Engine is GCP's platform as a service product. It's been around for a long time. We just celebrated the 10th anniversary. And all of the fans of App Engine like the ease of use, auto-scaling, security, and how well it integrates with all the other GCP products, like Data Store. And with this, Node.js now runs on every single compute platform that GCP offers. I told you could do anything with Node. So it's really important to me, and all of my friends over there dressed in red on the Cloud Developer Relations team, that Google is an active participant and a good citizen in our developer communities. After all, the best tools are written by developers who understand a community's needs and idiosyncrasies. And we like to put our code where our mouth is. And we do that by contributing to improving the languages and surrounding ecosystems. So that's why Google Cloud is a platinum sponsor of the Node Foundation, and it's also why there are many Googlers participating in Node in a variety of roles, giving their time and expertise to help guide the future of the language. So they only gave me a couple minutes today, and so I was only able to talk about a few of the popular languages, and even then, I only focused on their server-side uses. But client and mobile development are important and growing too. So next you're going to hear from Sam and Francis, and they're going to talk about Firebase development and development with GCP products for mobile.
Thanks, Aja. Our mission for Firebase is to help mobile app teams succeed by providing you a platform to help solve the key problems across the lifecycle of your app, from building your app to improving your app quality to growing your business. We've come a long way since 2 years ago when we expanded Firebase from a real-time database to a broad app development platform. And it's so exciting to see there are now over 1.2 million apps actively using Firebase every month, including many of the top Android and iOS apps like the New York Times, Box, and Pandora. Now, as you've heard earlier, Google Cloud offers a wide variety of products to help you build secure and scalable infrastructure. So when it comes time to build your mobile app for your business, Firebase integrates smoothly with GCP to help you build better and faster. To show you how easy it is to build an app with Firebase, I'd like to welcome one of my teammates, Sam, to join us.
All right. Hello. Thank you, Francis. So, one of the first problems that most mobile app developers face is finding a way to store and sync their data in the cloud, ideally without managing any infrastructure. Cloud Firestore was built to solve this problem on every platform that you work on. It's a fully managed NoSQL database built on Google's global infrastructure. Now, let's say I'm the developer of a financial services app called NextWallet. My users have been asking me for a long time to add a mobile app to complement the web app. Firebase helps you build apps on Android, iOS, and the web, but today I'm just going to focus on building an Android app. So here we're in the Firebase console, and we can see I've already got all my data in Cloud Firestore. This is a list of my recent transactions. I went to Sam's Place, and I spent about $45. Moving over to Android Studio, I want to load all of my transactions here. I want to display the user's recent transactions. So let's do that. Here, OK, so what I'm doing here is I'm getting the ID of the currently signed in user. And then you can see here I'm forming a query using the Firestore Android SDK. We're asking for the user's latest 50 transactions ordered by time. You'll also notice I can query this data directly from my app without building any API servers or proxies. I'm accessing the remote data as if it was in a local database. So if I run this in the emulator, you can see that all of the transactions from the console are now displayed in the app. And this connection is completely real-time by default. So if I go to the console and change the name of one of the places, change Sam's Place to Sam's Awesome Place, it updated in the app before we could even switch screens. So with barely any code, my mobile app is showing the same data as my web app in real time. Now, if you're used to accessing a database via a REST API, you may have found it strange that I did not include any tokens or headers in my request. That's because Cloud Firestore automatically detects that I'm signed in with Firebase Authentication and includes that auth state transparently. So every request from my app to Cloud Firestore is checked by Firebase Rules, which is a declarative system for controlling access to Firebase resources. So let's see the rules that are keeping this app safe. So these are my custom security rules. Here, I'm making sure that users can only read and write their own data. And here, I've locked down rights to transactional information to prevent any sort of spoofing. It's really powerful to have direct client access to your data without running any authentication servers or API proxies. It completely streamlines your development process, and even more importantly, it reduces the surface for bugs or for vulnerabilities. Now, with sensitive applications like this finance app, you can't do everything on the client side. If I need to add some critical business logic, I want to run it in a trusted location. So the newest feature in my app is that users can pay their bills. And unlike viewing recent transactions, this is a really privileged operation. So moving here, I'll write a serverless Node.js function to pay a bill from the user's bank account and then mark it as paid. And I'll deploy this whole thing to Cloud Functions. You can see here that I've got a function. It's called payBill. And after the bill is paid, it marks the paid state to true in Firestore. Now, in the Android app, we can simply call this function by its name, payBill, the same name I defined. And we can pass in the ID of the bill we want to pay. After the function runs, I'll get this callback here with the result. Just like with the data call to Cloud Firestore, our authentication state is passed seamlessly in the request. So users can only access their own bills. So now let's use it. Let's pay a bill. Hit this here. And what just happened was the Cloud function ran and made the update, which was detected by the client in real time. So in just the last few minutes, we set up a secure, scalable, and real-time connection to our data, and also deployed a Cloud function to perform trusted actions, which is pretty impressive, right?
Once your app is built, you'll likely be looking to improve your app's stability and performance, since the first impression your app makes is crucial to the long-term success of your business. Now, we've seen through Google Play that 42% of one-star reviews mentioned instability or bugs, whereas 73% of five-star reviews mentioned design, usability, or speed. So having a stable and speedy app is essential to your success. So let's switch it back over to Sam to take a look at some of the ways that Firebase helps you improve your app quality.
So as a mobile developer, I have to release my code into the wild, and it could end up on any kind of device or any network. I need to know how it's performing, and more importantly, I need to know when it's crashing. If I wait to hear about crashes in bad Play Store reviews, that's way too late. So all I have to do to track crashes in this app is add this single-line dependency on Crashlytics. I don't have to write a line of real Android code. Now, let's go into the Firebase console and see what crashes are happening for my users. So here I can see that I had a crash, but I don't know why yet. Let's take a look at the trace. I can see that it was a fatal exception, and I can see the exact line where it occurred. I can also see some information about the device where it happened and the environment. Through an integration with Slack, I can get new crashes like this sent to me and my team in real time. Now, here in the logs panel, I can see we have a list of analytics events that preceded the crash. Event logging from Google Analytics to Crashlytics is automatic, and it provides really helpful context. So now I have a ton of information on what the user is doing to cause the crash, which allows me to debug my app more efficiently. I could spend more of my time and my team's resources on building features for my users. And now that we can measure if the app is stable, I still need to directly measure the goals of my business. So for the new bill pay feature, I want to make sure that users are able to find the tab in the app, pay the bill, and that it all runs successfully. Firebase provides free unlimited mobile analytics and automatically measures common events in your app. But I want to add custom analytics for each bill pay event for the attempt, success, and the failure, so I can track user behavior here. So if we move back into Android Studio, in the bill pay flow, I'll add calls around the common parts of the flow. So here I'll log the attempt, here I'll log when it succeeds, and here I'll log when it fails. You can see that for each event, I just pick a name, and then I pass a bundle of parameters. Now that the code's running, if I go back into the app and pay a bill, those events will fire. Heading back into the console, I can see these events coming in real time. By defining custom events, you can measure the things that uniquely matter to your business. Analytics is the backbone of Firebase and the foundation for a successful business.
Having the right analytics is the first step to ensure your users are happy and your app is doing the job you want it to do. But once you have the data, you want to put it to work for your business. With Firebase, you can export your analytics data into BigQuery, join it with other data sources, and perform deeper analysis. You can also take action right directly from the Firebase console, and it comes with a built-in A/B testing framework. So for example, you can send push notifications or test different configurations of your app without having to redeploy to the App Store or Google Play. With A/B testing, you can define different variants, set the primary and secondary goals for your experiment, and the system will automatically do the hard work for you to help you find the optimal variant. And once you have the winner, you can roll that experience out to the rest of your user base without another app deployment. Firebase also helps you take targeted action by leveraging machine learning. Now, it's one thing to take action based on past user behavior, but with Firebase predictions, you can apply ML to your analytics data to take targeted actions based on predicted future behavior. So for example, you can send special offers to users who are likely to leave your app. Or in Sam's example, he can send push notifications targeted to users who are likely to miss a bill payment. So predictions was the first step that we took to bring the power of Google's ML to work for you. 2 months ago, we took our second step with the release of MLKit in public beta. With MLKit, we're bringing together machine learning technologies from across Google and making that available to every mobile developer working on Android and iOS. MLKit comes with 5 APIs out of the box, like image labeling and text recognition. And you can run these APIs on device for low latency processing or in the cloud for higher levels of accuracy. And if you have more sophisticated needs, you can upload your own custom TensorFlow Lite model and serve that through Google's global infrastructure. Your app can dynamically retrieve these models and evaluate them on device, so that means you don't need to bundle the model with your app binary, and you can update it without pushing an app update. And since MLKit is available through Firebase, it makes it easy for you to take advantage of the broader Firebase platform. For example, experimenting with different custom models using A/B testing, or storing your image label into Cloud Firestore, or understanding the impact on user engagement with Google Analytics. We are so excited about the possibilities that machine learning unlocks, whether it's to supercharge your growth or build amazing user experiences. We want to harness Google's advances to help you build and grow your apps. And with that, I'd like to hand it over to Yufeng to talk more about Cloud AI. Thank you.
Thank you, Francis. Hi, everyone. My name is Yufeng Guo, and I'm a developer advocate here at Google Cloud. Over the past 4 years that I've been at Google, machine learning has taken on a greater and greater prominence in both our internal usage as well as in our external offerings. Today, I want to provide you with a user's guide to thinking about machine learning problems. We'll talk about how to find the right tools for your task depending on your needs. And we'll discuss 4 groups of tools and workflows that can be used to drive insights to build your applications. Machine learning APIs, data processing, model building, and scaling up. Let's start with APIs. Say you have some video or sound data that you want to annotate with labels and transcripts. Historically, this would have been a challenging and manual task. The Video Intelligence API allows you to turn a video into a set of labels and scenes to build understanding, while the Speech API can turn sound into text. This means you can now focus on doing something useful with your newly tagged audio and video files instead of getting stuck on how to label and transcribe it all. Additionally, there's the Video API, the Natural Language API, and the Translate API, which handle images, text, and the many languages of the world, enabling you to easily transform and augment your existing data. Together, you can think of these 5 APIs as simple building blocks for your application. They're literally just REST APIs that you can call and get JSON back. Now, if these pre-trained APIs don't give quite enough detail for you, you can customize them to produce state-of-the-art models using AutoML for vision, natural language, and translation. All you need to do is provide the data for your specific use case, and AutoML will train up a custom API endpoint just for your particular interest. So that's the story of the machine learning APIs. Easy to use and simple to customize. But what about other forms of data? Let's say you've got a data scientist at your company, or perhaps you are the data scientist at your company. And this data scientist, she is chomping at the bit to get her hands on as many data sets as possible, to find interesting relationships that might exist. But alas, your data is big and it's messy. It's stored in a variety of formats and places. How can we use machine learning to get some meaningful outcomes out of this, well, pile of data? First, I want to clarify that machine learning is not magic, but rather it essentially boils down to using many examples to make predictions, or at least try to make predictions. And so a large part of the work is around getting the data organized. And because data is often stored in a variety of places, for good reason, I'm sure, gathering it together where possible is a good first step, before then trying to see and get a sense of just what it is you're dealing with. And how might you do that on GCP? Perhaps you explore it in BigQuery, run some pre-processing on Dataflow or Dataproc, and take a peek at the results in a Jupyter Notebook. Or perhaps you run the data through Dataprep and output the results to Cloud Storage and save some metadata to Cloud SQL. However you approach it, careful management of your data is the key factor in being able to do any kind of meaningful analysis and, of course, machine learning. So be a good steward to your data, and it will reward you. OK, so let's say we've got all our data set up and ready to go. It's been turned inside out, upside down, and arranged just right. What's the next step in our data scientist's journey? It's time for her to make some models. If she's already got a data set stored in BigQuery, thanks to all that work and getting the data prepared, it may be worth running some, say, linear regressions directly in SQL using BigQuery ML. And for a more sophisticated approach, she can look to TensorFlow, Google's popular open source deep learning library. It's flexible and extensible, but best of all, runs on all manner of platforms, from CPUs and GPUs, as well as mobile and web. Initially, she'll most likely run TensorFlow on her local environment, say in a Jupyter notebook. Maybe she samples a subset of the larger data set from the cloud and builds a few different models to try out different ideas she has. Running TensorFlow models against a subset of the data is all well and good. But then when it comes time to train some models on the full, real data set, running everything on her local laptop is probably not so realistic. Just getting the data downloaded would take a while. So if we can't bring the data down to the models, let's bring the models to the data by running machine learning in the cloud. Imagine being able to train a model in the cloud by just sending up your TensorFlow code and virtually nothing else. That's basically what training a model on Cloud ML Engine is like. You can train a TensorFlow model at scale without needing to configure machines or install libraries. You just don't have to fiddle with that stuff. Now, this has three very important implications. First, it means you can kick off multiple training jobs in parallel, allowing you to try out different approaches with different data sets. And then, well, you can just go get a coffee. Second, Cloud ML Engine features a hyperparameter tuning service that runs in parallel and uses Bayesian optimization to try different variants of the same model and find the one that has the best performance. And third, running TensorFlow training on Cloud ML Engine gives you access not only to CPUs and a whole lot of GPUs, but also TPUs, Google's custom accelerator chip built for deep learning. Now, once your model is done training, it's time to serve predictions. And as most of you know, standing up a production server is no easy feat. But with Cloud ML Engine, there are just 3 steps. Are you ready? Step 1, provide a name for this version of your model. It can be whatever you want. Let's call ours version awesome. Step 2, provide a location where the exported model file lives. And step 3, click Save. OK, so we did our 3 steps. What did that get us? We've actually already got ourselves an auto-scaling REST API that can be called from any internet-connected device on the planet. And if you thought that's neat, wait till you find out you can also run your existing models that are using, say, scikit-learn and XGBoost on Cloud ML Engine as well. So you can have just one workflow to train and deploy models to the cloud, regardless of whether it's using traditional approaches or deep learning approaches. Machine learning, it's not easy. But when you take our suite of cloud-native serverless tools to ingest, transform, and manage your data, and then combine it with TensorFlow and Cloud ML Engine, you'll be well-equipped to journey into the next generation of intelligent applications. And if you're ready to dive deeper into machine learning and data science, check out Cloud AI Adventures on YouTube, which explores the art, science, and tools of machine learning. You can catch it at YouTube/AI Adventures. But I know videos aren't for everyone, so here to tell you more about where you can find a community of learners who are supporting each other to grow in their skills and share in their knowledge is Anthony Goldblum, CEO of Kaggle.
So thanks, Yufeng. I'm Anthony Goldblum, CEO of Kaggle, and it's really nice to be back on the next stage. It was actually on this stage last year that we announced that Kaggle was joining Google. So for those of you who don't know Kaggle, we are the world's largest machine learning community. We're going to pass 2 million members in the next couple of weeks. Now, at the beginning of the show, Adam asked how many of you had deployed a machine learning model, and it seems like not very many. We want to change that. We want to be a part of your entire machine learning journey. Our community ranges from people just learning Python through to the researchers behind deep neural networks. Kaggle rankings are probably the most widely recognized machine learning credential at this point, and so we've seen many in our community going from being total newbies to having elite AI roles. So the Kaggle community started out with machine learning competitions, and so a lot of you will think of Kaggle as machine learning competitions, but we've expanded well beyond that. If you're a software engineer, you go to Stack Overflow for your question answering, and you go to GitHub for code collaboration. What Kaggle's trying to do is be the one place you go for your as a community member, as a member of the machine learning community, we're giving you the one destination you need to go. So in addition to competitions, we offer several other things. We offer Kaggle Learn, which is short-form AI education. We offer Kaggle Kernels, which is a cloud-based workbench for data science and machine learning. And we have a datasets platform where we have almost 10,000 datasets that have been shared among our community. And so I'm going to give you a tour of each of these parts of Kaggle and help to show you how they fit into your machine learning journey. So if you're brand new to AI and machine learning, I suggest starting with Kaggle Learn. As I mentioned, this is very short-form AI education. So if you go to Udacity, the main machine learning course takes 6 months. Kaggle Learn has you training your first deep neural network in 30 minutes. Now, we're not teaching you everything there is to know about deep neural networks in 30 minutes, but what we are doing is we're giving you enough of a basis to get going on your own projects. So we have a cloud-based environment called Kaggle Kernels, and you can use it with Kaggle Learn, but actually you can use it for most machine learning projects now. Kaggle Kernels allows you to avoid the pain of setting up your own environment. So we give you a cloud-based environment and a browser in the browser that will give you machine learning with most of the major packages that you could want. We are strong believers that the future of data science and machine learning is going to be done in the cloud in an environment like Kaggle Kernels, hopefully Kaggle Kernels for you. And the reason being is that machine learning workloads are very bursty. 1 minute you're exploring your data, the next minute you're training a very large deep neural network. So the cloud is perfect for such workloads. So you can with Kaggle Kernels, you choose between a Jupyter Notebook interface or a normal IDE. You choose between Python and R, so those are the two main data science machine learning languages. And by default, we give you a CPU, but you can also have access to a GPU if you want more compute. You can see your data sets and see previews of your data set, and the code executes in our servers, on Google Cloud servers. So you get 6 hours of compute per session at no cost. So actually, this will cover the majority of your machine learning workloads. Okay, so through Kaggle Learn, you've learned an algorithm. Through Kaggle Kernels, you have an environment set up. Now you're ready to start working on a project, and we have 2 projects at Kaggle that you can work on. We have Kaggle Competitions, and we have our datasets platform. Now the way competitions work is a company will post a problem, and data scientists and machine learners compete to build the best algorithm on that problem. So at any point in time, we're running 10 to 15 competitions. Right now, if you come to the site, you'll see we're working with Zillow to improve the Zestimate home valuation algorithm. And we're also working with CERN to build an algorithm that better detects particle collisions in the Large Hadron Collider. And I like showing those 2 use cases because they give you a sense of sort of the breadth of machine learning and how it's applicable. Those are totally different use cases, right? And it's applicable to both. Now, during the competition, you can see on the second cube, you can see a live leaderboard, which shows you how you're performing relative to others. So it also shows you, if you're not in first place, it shows you how much better it's possible to do. So if you're scoring 50%, somebody else is scoring 90%, they've found something that you haven't found. Very rewarding also, while you're participating in the competitions, we have forums where people are sharing techniques and ideas. And so you never run out of ideas of things to try. All you need to do is read the forums if you're running out of ideas. And actually, at the end of the competition, very often what we'll see is the top performers will share the results of their model in the forums, or sorry, the approach they took. So you kind of get to learn what the right answer is. All right, so our datasets platform is the other place you can go and do projects. And this is really good for more free-form projects. Our community has shared almost 10,000 datasets at this point. So even if you have your own dataset that you want to work on, rather than working in isolation on your local machine, why not bring it to Kaggle? And then others who are also interested in that data set will work on it with you, right? You'll attract like a small community of people who are interested in the problem you're working on. On the flip side, if you don't have a data set that you're itching to work with, as I said, we have almost 10,000 data sets, and the range of topics is kind of breathtaking. I'll show you in a minute, but there is almost certainly a data set that meets your interests. So I'm going to show you what it looks like to work on our datasets platform. here I'm browsing the data sets that others have uploaded. And I find a data set on avocado prices. I like avocado toast, so I figure I'll jump into this one. And rather than starting from scratch, I start looking at what others have done on this data set. And I notice that somebody called Samuel Belko has already written a forecasting model. And his forecasting model has done exactly the kinds of things that I would want to do. You can see, I'm scrolling quickly, but you can see he's done some exploration, he's doing some charting, then he uses quite a well-known time series forecasting package in order to make a prediction. So you can see I hit the fork button. And that gives me, when I hit fork, what's happening behind the scenes is I'm forking the code, the Docker container, and the connection to the data. So I get his code in an environment that will run it immediately. And so you can see I'm scrolling through, I have exactly the same code that he has. And then when I start executing the cells, I'm getting the same results that he gets. So as I dig into his results, I noticed that avocado prices rose pretty dramatically in 2017, and I want to build a model that sort of fits that period nicely and explains that period nicely. So I go in and I add a data set, and I add a data set with Starbucks locations, which at first glance sounds kind of odd. What do avocado prices and Starbucks locations have to do with each other? Well, it turns out that Starbucks rolled out an avocado spread nationwide in 2017, and so when I add in the data set on Starbucks locations, it helps me to evaluate the impact of the additional Starbucks demand on avocado prices. So you can see how I can go and extend Samuel's model by adding in an extra data set and adding that data set into the model. If I wanted to grab weather data as well, almost certainly we have a weather data set for some of the main growing regions, the avocado growing regions. So maybe that had an impact on supply. So hopefully that gives you a sense for how much, how many learning opportunities, how many interesting data sets, how much there is to do on the Kaggle Datasets platform. So as I said at the beginning, Kaggle wants to be a part of your whole machine learning journey. And so over the coming year, you'll start to see us add in more commercial grade features. You'll start to see us allow you to connect your Kaggle accounts to your GCP accounts. You'll be able to access the data sets you have in BigQuery. You'll be able to deploy your models to Cloud ML Engine. And so you'll get both the content that has been shared with the Kaggle community, plus the power of GCP's data analytics and machine learning services. So for those of you who haven't yet deployed your first machine learning model, who aren't yet a part of our community, we'd love you to sign up. We want to help accelerate your machine learning journey. So Kaggle is one of the great communities around GCP, but next on stage we have Sam O'Keefe, who heads up Google Cloud for Startups. And Sam is going to talk about some of the other communities we have around GCP. Thank you.
Thanks, Anthony. Kaggle and GCP's machine learning tools are just a few examples of the way that Google's values manifest in the tools and technology we create. I hope you've heard by now, but just in case, we are committed to openness, and we want all of you, the community, involved. Next up, we'll hear from one of our close partners who shares those values, Unity Technologies. We recently announced that GCP would be powering the Unity platform. With this seamless integration, game developers get to focus on what they love, being creative and building immersive experiences for their users, while we take care of the infrastructure. Let's take a peek. Here to tell us more, please welcome Suhail Dada, VP of Cloud Services for Unity.
At Unity, we believe the world's a better place with more creators in it. So whether we're helping Steven Spielberg shoot Ready Player One on a virtual set, or working with NASA on visualizing the Mars rover, empowering Lexus to design and market the LC500, or providing Ludia with the tools to create Jurassic World Alive. Unity is the most widely used real-time 3D development platform, and we're empowering millions of creators to achieve their aspirations. At Unity, we live by 3 principles: democratize development, solve hard problems, enable success. One of the hardest problems in gaming is building what we call connected games. So games that help their players connect and play with each other are easily the most influential games out there. They're the most played, the most watched, and the most successful. In fact, 90% of the top grossing apps on Google Play are connected games. But creating them is hard. Building an experience that delights your users all across the world requires a lot of infrastructure. The time and expertise to manage it, and 24/7 support. At Unity, we want to change that, and so does Google. Last month, we announced a strategic alliance to help simplify the development of connected games. And we're doing this keeping 2 tenets in mind: scalable and approachable. Scalable, so you can create your game the right way from day one, whether you have 1 player or 1 million. And we do this with efficient, high-performance networking and enterprise-grade server hosting. We also use our tools and services to provide a seamless integration between Unity and Google Cloud, so you can get started quickly and focus on what you do best, creating great experiences. Our first collaboration, a service that helps match players into games based on an open-source matchmaking project, is coming out later this summer. It's called Open Match. Not only do we believe that Google Cloud is the right cloud for our customers, but we're also migrating our infrastructure over to Google Cloud. Together, we're making it easier for you to build and operate your connected experiences. We can't wait to see what you create. Thank you.
Unity's developer community continues to demonstrate that with the right tools, small teams can build products that reach and are enjoyed by millions. I have the unique opportunity to witness this every day as part of Google Cloud for Startups. At Google Cloud for Startups, we help developers from all over the world get their businesses up and running on GCP. We do this by providing access to content to help you learn, and technical mentors for when you get stuck. Access to Google products at a discounted rate, so they're affordable when you're in your garage phase. And most importantly, access to a community of peers facing and solving the same technical and non-technical challenges that you are. In keeping with our theme of openness, Google Cloud for Startups truly is for everyone. From 2 developers working on their first MVP, to a team that just found product market fit and is figuring out, how the heck are we going to keep this thing going? Google wants to be there. You can get started today by going to our website, and we'd love to meet you. In the past year, thousands of startups have made the decision to build with Google. You saw a few of these startups in the video earlier, but they're really doing everything. They're leveraging machine learning to structure healthcare data, using IoT devices to create factories of the future. And if you're here in the Bay Area, they're putting everything on the blockchain. Today, I'm excited to have 2 startups here to share their story and show us all what's possible with Google Cloud. As we heard in Aja's talk earlier, JavaScript is one of the most popular languages today. So our first startup might be familiar to many of you. NPM provides the largest software registry in the world, enabling over 11 million JS developers to build web applications. Please join me in welcoming CTO CJ Silverio as she tells us how a team of 3 engineers gets it done.
How many of you here work for a company that has a website? Website? Anyone? Yeah, your company has a website? Great. You are my user. Hi, I'm CJ Silverio, CTO of NPM Inc. Now, NPM powers the world's largest registry of open source software. If you have a website, use any modern front-end framework, your developers type npm install. You use us because we're how the world shares JavaScript. I'm here today because our team took our global registry and created an enterprise-ready version of it to help developers at big companies use open source code at work. We did it using Google Kubernetes Engine. NPM's registry is a complex distributed system. It stores data in 3 different databases and a cloud object store, and has the usual thicket of microservices shuttling that data around. It was designed to make it easy for us to scale the registry to 1 billion downloads a day, supporting our 11 million users, all of you. It's massive and it's reliable, to the point that people don't even think about what happens when they type npm install. Here's the twist. We had enterprise companies asking us how they could have their own private NPM registry, all the features of the public registry, but meeting their greater need for control over their source code. The challenge was to take a super redundant architecture that sprawls across hundreds of cloud instances and package it into something easy to install, manage, and operate. That's a lot of complexity that has to be reduced and delivered to a single customer. Did I mention that NPM is a small company? Because we are. And we already have a full-time job running the world's largest registry of open source software. Containerization was clearly the way for us to go with this. And for the first version of this product, we containerized. But we did that with a hand-tuned, single-size container deployment, and we ended up with something that was hard to scale and hard to update. When we looked at doing another take on it, we knew we had to use Kubernetes. Now, just saying, yeah, Kubernetes is not an answer. You have to install Kubernetes, you have to manage it, and you have to operate it. And then you have to scale that to demand as we bring in new customers and as our customers grow and add users and packages. So the idea of building all this infrastructure ourselves was daunting. Google Kubernetes Engine, though, had exactly the API we needed. It might sound like a line fed to me by marketing, but it's literally true. Give me a cluster. Here are my compute and memory requirements. Go. GKE gives me a cluster. Now, I need a place to store my customers' data and keep it backed up. Google Cloud Storage is right there. Now, I need isolation so I can manage and bill each of our customers separately. We use GCP's projects within our Google Cloud organization to keep our customers' resources isolated. So, no joke, a few months later, a single team of 3 developers built and shipped an all-new NPM enterprise, and it's serving customers now. You can run the exact software that the NPM registry runs with your own authentication in a single-tenant environment, all on Google Cloud. We can provision a cluster, scale it, keep our customers upgraded, and I didn't need to hire a staff that's expert in Kubernetes to do it. Enterprise customers get all the features the public registry gets, at the same time it gets them. Using GKE shaved a year off of our development time and let us focus on what we do best, building amazing software. NPM's mission is to reduce developer friction for every single software developer in the world. GKE reduced friction for us so that we can deliver this amazing thing to you so that you can build amazing things yourselves. Sam, we're big fans of GKE, and I'm super excited for what's ahead.
I am too, and congratulations on everything you've accomplished so far. Thank you, CJ. I don't think it'll be a surprise to anyone in this audience when I say that data is critical to machine learning. Much like how Google's Fei-Fei Li created ImageNet sparked a frenzy of advancement in the field, our next startup is building a massive data set of their own. This time, that data set consists of millions of microscopic images of human cells. Armed with this data and Google Cloud, Recursion Pharmaceuticals is on a mission to redefine the drug discovery process and bring life-saving drugs to market faster. Please join me in welcoming Lena Nielsen, Senior Director of Data Science at Recursion Pharmaceuticals, to tell us more.
We are decoding biology in order to find new medical treatments. I am Lena Nielsen, and I am incredibly excited to be here today to share with you Recursion's vision for the future of drug discovery. The number of new drugs approved each year by the FDA has been essentially stagnant since the 1980s, and the development cost of each of those few drugs has increased tenfold to well over $2 billion. Contrast this to the world of tech, where costs are coming down all the time, and where the smartphone in my pocket has more compute than a 1980s supercomputer. So why has drug discovery not followed this same pattern? The traditional scientific workflow is sequential. Researchers work on one disease and one hypothesis at a time. This works, but the rate of finding new treatments is slow. At Recursion, we're transforming this old process into a new formula where we test dozens or even hundreds of diseases at once. And instead of testing one hypothesis at a time across that data set, we're able to be open to millions of possible outcomes in an unbiased way. And this new formula gives us the ability to dramatically speed up the discovery of new drugs. The key to all of this is a combination of, one, large-scale biology on our automated robotics platform, then two, prediction and inference on the cloud, and finally, rigorous biology validation in the lab to complete the drug discovery process. So let's dig in a bit, and I'll show you a bit more about how this all works. The first step is automated robotics. Recursion has built an automated lab full of robots that run about 100,000 experiments every week. This gives us 2 million biology images to work with every week. By the end of this year, we'll have the capability to generate nearly 1 petabyte of image data every month. This dwarfs ImageNet. And these biology images are then streamed to Google Cloud and are run through our data processing platform, which leverages Google Kubernetes Engine, BigQuery, and of course, Google Cloud Storage. And this is what those microscope images of human cells look like. Each image you see shows a different cell type, exposed to different diseases, and of course, different potential treatments. But generating millions of images alone, that's not really going to help us reach our ambitious goal. It is only transformative when we layer on machine learning analytics on the cloud in order to discover important patterns in the data. Using preemptible virtual machines, for example, our workloads can spike to do all this image processing and deep learning inference using TensorFlow. And that allows us to iterate rapidly and to develop new powerful machine learning models in a really cost-effective way. So let me give you one really powerful example of a model. So here we built a unified high-dimensional representation latent space to help us identify the most likely drugs to work for a given disease before we even run that test in the lab. So here I'm showing just a small subset of this latent space data in a simplified 3D graphic. So essentially taking thousands of dimensions and turning that into something that's visually interpretable by humans. The red dots indicate the results of adding disease to human cells in our lab, and the blue dots represent a separate addition of drugs to cells in the lab. The closer two dots are, the more similar their effects on human cells, and vice versa. So it turns out that drugs tend to cluster on the opposite side of the latent space from the drugs that they work on, so the diseases that they can treat. So while not a perfect predictor, this means that we have a data pattern to help us identify drugs that are likely to be effective. Or to put it in another way, these blue dot diseases, drugs you see here, are likely to be effective against the red dot disease on the opposite side. This is really powerful because it means that for the first time, we do not have to test every drug against every disease in the laboratory. We can predict already on the cloud which drugs are likely to work. And this is the type of approach that saves our scientists tons of time and tons of resources. And it's also an example of the kind of capability Recursion is building out in order to be able to exponentially increase the efficiency in drug discovery. And that brings us to our final step, step 3. Our team of biologists validate and follow up on all of our results. Robotics, machine learning models, and human biologists then work hand in hand together to speed up all the steps of the drug discovery pipeline, from in vitro to in vivo, and then eventually human medical trials. In fact, using this new formula, Recursion already has one drug cleared by the FDA for human medical trials, and we have a pipeline of dozens of other drugs behind it in just 5 short years. This is a tremendous volume, not just for a small startup like for Recursion, but for any biopharma company. We are on a journey to decode biology and to find cures for today's untreatable diseases. I hope you are inspired to join us. Thank you.
All right. Hey. All right. Was that a fun time or what? Yeah. So I want to recap, our promise to you, our commitment to you. The first is around innovation, the second is around openness, and the third is about being part of a community. Now, I've got something to announce that I want you to pay attention to. I'm incredibly excited to announce that our community is running DevFest, community-organized developer events in 500 cities, starting basically in a couple of weeks. So I hope you all find a local one. Get plugged into that local community. I want to thank all of you. Thanks for your participation. Thanks for your feedback and your challenge. Now, we're going to do something. Another thing I want to tell you that we're going to do now is we're going to officially announce a save the date for the next April 9th through 11th in San Francisco, right here. Pretty cool? Okay, we've got a bunch of engineers coming up now who built these products for you to ask them anything. And I would like to invite Head of Open Source Strategy, a great leader here, Sarah Novotny, to come up and welcome all our panelists. Check this out.
Thank you, Adam. You've had an opportunity today to ask us anything you want about the future of cloud. So for those of you who are registered for Next and who are registered for this AMA session, you'll be able to put questions into our Dory. For those of you who haven't seen this special peek at a Google internal tool, here's your chance. We use this tool to capture votes on questions for large groups. Dory is named after a Disney character who constantly asked questions. If you've missed the instructions and haven't interacted with the Dory yet, here's a quick 15-second recap on how to log in to the Cloud Next app, and then go ahead and navigate to the session, today's session. We've got information here. Click on the Dory Q&A, and then put in questions and vote on others. We'll get started on these questions as soon as we finish our introductions. I'm going to be joined here on stage by 4 fabulous panelists, so could they come join us? As Adam said, I am the lead of the open source strategy group here at Google Cloud Platform. I've been an operator and a developer in past lives and have spent a lot of time in the MySQL, OSCON, Nginx, and Kubernetes communities. I'm joined today by 4 fabulous panelists, and let's listen to their introductions while you keep adding to the dory and voting on questions. To my left is Brad Fitzpatrick, who has been working in the Go programming language for more than 8 years. Previously at Google, Brad has also worked on Android and has added Memcache support to App Engine. He's also worked on Gmail's contact backends. Prior to Google, Brad created LiveJournal and much of its internal infrastructure, including OpenID and Memcached as open source projects. Brad, can you tell me something you're super excited about in the future of cloud?
I'm pretty excited that everyone lets you bring your own container now, and I'm excited about being able to scale from 0 to 1 and 1 to 0 really quickly with my own code and not being, locked in, like what I thought of like the traditional like App Engine standard sandbox. So
constraints are good, but constraints can be constraining. Yeah. Excellent. Next up in the lineup, you may recognize him from his time earlier on this stage, is Kelsey Hightower, staff developer advocate for Google Cloud. He's a technologist who is focused on finding simple solutions to complex problems. Kelsey, one thing you're super excited about the future of cloud?
The cloud being open. So all the technologies in the cloud, I can actually run most of them on my laptop.
Yeah, that's a great way to look at it, too. We're also joined by Eric Brewer. And once he joined Google, he leads the company's compute infrastructure design, including Google Cloud Platform. As a researcher, he's led projects on scalable servers, network infrastructure, IoT, and of course is known for the CAP theorem. He's also led work on technology for developing regions with projects in India, the Philippines, and Kenya, among others. Eric, what is something you're super excited about?
I'm really glad to see that we are bringing together serverless and Kubernetes, and I think that's a lot of traction there.
Knative, yes. I'm sure we'll get questions about that. Just guessing. And finally, it gives me great pleasure to introduce Jia Li, the head of R&D for Cloud AI and the adjunct professor for Stanford School of Medicine. Her team at Google focuses on both research and innovation, solving real-world problems and developing the full stack of AI for products on Google Cloud. Jia received her PhD from the computer science department at Stanford University. Jia, what is exciting about the cloud?
Democratize AI and advancing AI.
Democratizing and advancing AI. There are so many opportunities ahead of us. Now, I'm hoping that we've tap danced up here long enough to get you some time to get questions into the dory. And I see one, which has popped up already. So we expected this one possibly. Will serverless eventually make containers obsolete? So, Eric, you started this.
Absolutely not. Serverless is about not having servers. In fact, you'll still have containers. You may not need to know about them. If you provide just a function, and we can take it from source to container to deployment, the container is invisible, but it's still there. But eventually, you're going to want fine-grained control of exactly what it's doing and exactly which libraries you use, and the container is the mechanism that you need for that control. So actually, you can do more with containers and serverless than you can do with serverless by itself.
And I also think it's important to understand what serverless is. It's not the fact that you're not using containers. That's not what serverless is.
Or not servers, even.
Or not servers, even. But if you think about the architectural patterns of an event-driven workflow, to map these events to a piece of execution, AKA the function, and there's some nice properties of scale to 0 and pay per use. All those things can actually be done with containers at the underlying primitive.
Okay. Anyone else have thoughts on serverless versus containers? Because it is a thing that we keep hearing about. I do love the fact that everyone needs to be reminded, serverless isn't really serverless. It's just You don't have to think about the servers.
There are still servers somewhere.
There are always still servers somewhere. There are servers and then there are containers. It's one of the things we say that we want containers to be boring 5 years from now, because infrastructure needs to get more boring.
I was just going to add that serverless tends to mean little functions, but there's many things at Google that I would say are actually serverless that are much older than the modern use of functions. That includes App Engine from 2008, but also Cloud Data Flow. It's AutoML serverless. You're not setting up servers for it. So there's lots of things, depending on how you define them, that have been serverless for a long time. It's about the ease of use and the productivity and the usage-based billing more than the actual deployment mechanisms.
Most of software as a service could be considered serverless.
Yes, indeed.
Yeah. OK. So on to our next question. After TPU, what would be the next application or workload that is likely to drive custom silicon? Do you have ideas, Jia?
So, as you know, TPU has been significantly accelerate machine learning tasks. We're looking forward to have more custom chips that could help us to do even more advanced machine learning applications. Yesterday, we've announced Edge TPU that you can do machine learning deployment on custom chips on the device, like Internet of Things. And we're looking forward to more hybrid learning and large-scale training on cloud and flexible deployment on mobile and other devices in the future.
Anyone else have things that might end up on chips?
Broadly, that we have to invest in a wide range of accelerators in the next 10 years because of the slowdown in Moore's Law. There isn't really an alternative way to get the same kind of performance we've enjoyed the past order 50 years. And so TPUs do one kind of machine learning, but I think there are other kinds of machine learning that should be subject to acceleration. We're doing a lot of acceleration for some of the networking things that are a little bit more invisible, but they are there, custom silicon for networking. And we'll continue to have to look for new opportunities because, again, the general purpose CPU is not going to get us where we want to get by itself.
Totally. There will be a lot of high-performance computing that beyond the AI applications as well.
Well, we saw this start with the specialized need of graphics. And then now, so as we find more things that are compute intensive, they can get offloaded easily onto new silicon. Yeah. OK. So the cloud right now seems to be pretty synonymous with containers and Kubernetes. It wasn't always that way. Well, it was always that way at Google, but it wasn't always that way in the broader world. What do you think that the evolution of Kubernetes and containers 2 and 5 years from now might be? I've already said I think they should be boring and commoditized and not something that most end users or end developers think about or engage with. Any of you want to jump in? Brad?
I'm seeing Kubernetes becoming more and more of like the cluster operating system.
Yeah.
So I've been kind of building a crappy data center in my garage to kind of keep me grounded to like remember how non-cloud stuff works. And it kind of started with the idea that I wanted to build like a highly available, kind of setup in my garage. And so I wanted at least 3 machines. And then I was thinking, how do I take, 3 machines and make them like act like one highly available machine? And it was this whole world that I hadn't really like been in outside, being at Google for about 10 years or so, that I forgot how, all this sort of, I take for granted all this sort of stuff now. So there's this whole world of people running, VMware, people running like Proxmox, and other people now are trying to just like say that the base operating system image that these all run is Kubernetes. And then people are running, VMs on Kubernetes with a KubeVirt, and people are having all their operating system services just being like pods running on Kubernetes. So it's kind of like early days there still. You can't really just like install a Kubernetes distro on 3 machines and have like a highly available 1 machine or 2 machines. But it's getting there. So.
Yeah, I think when it comes to the evolution of Kubernetes, we've started to see it a little bit. So when I look at Kubernetes, it's a platform for building platforms. The first platform we built was a container management platform. Most people kind of see that, run these Docker containers spread across a couple of machines, add a scheduler. And then you kind of see it becoming a framework for doing things like network fabric in terms of like Istio. So when we look at Kubernetes, if you take out the API part, we call it API machinery. And API machinery can be used standalone to build things like a CI/CD system. You can use it to build a storage system, a network system. So we think the industry will evolve given this really declarative API. So the workflow of Kubernetes of versioned APIs being declared and a bunch of control loops that are enforcing state. We've seen this pattern in the config management space and promise theory, if you've been following that stuff. So I think Kubernetes is one of the best implementations to get people towards that promise theory model if you decouple the API machinery. And then on what we have now with the container platform, it just needs to get stable. It doesn't need to do everything. Tools like Knative will lay on serverless on top. There'll be other workflow engines that lay on top. But Kubernetes itself and its core primitives that we mark with V1, they just need to get stable. Everyone understands the APIs, and then we just need to make all the integrations solid.
Yeah, I think there's a lot of the next few years will be about getting the lower layers unexciting. It's going to take a while, not because I think it's hard to stabilize something. It's because we still have a high rate of innovation at many different layers, right? And if you look at what changes quarter to quarter in Kubernetes, every quarter changes a lot of stuff, right? So we're going to be in that mode, even at the lower layers, I think for another few years. And in some ways, I'm sorry for that, because it means it's going to have continual effort to keep up. But at the same time, that's tremendous functionality added on a consistent basis. And we'll build on that. I also agree that the CRDs, custom resource definitions, that let you extend Kubernetes for things like serverless, for things like kubeflow, those are also, I think, a big part of the future, the kind of domain-specific uses that are more narrow, but are better for those use cases by a lot. And Kubernetes, as a platform for platforms, is really you'll see a lot of those, especially, I think, in the next 18 months.
And there's a layer you've been involved in, which is the container runtime piece, right? Multi-tenancy is still an issue. The idea that we can do multi-tenancy at the API level in Kubernetes with RBAC rules, who can see this secret, who can make this config map. But then once you deploy all those containers on the same machine, now you're back to the tenancy problem of a shared kernel, and the work we just released around gvisor attempts to solve that.
No, I'm a big biased person on the gvisor front, so take it with a grain of salt. But it was started in about 2013, 2014, roughly the same time as Kubernetes for the same reasons, which is to try to get the kind of internal model we had at Google of containers are the unit of deployment, and every machine is multi-tenant, with, as a way to get high utilization and as a way to support both giant services and small services on the same infrastructure. That vision, I think, is still right. gvisor is really my preferred mechanism on how to actually have a secure, isolated process group, right? A pod. Right? That's the model of internal Google. That's the model of Kubernetes. And I think that's the model that's very productive versus thinking of machines as your unit. Really, it's process groups. And that means they can grow and shrink. They can have identity. You can know what they're doing. Much more flexible. So we're pretty excited about that direction. You'll see more on gvisor for sure over the next several years.
And Jod, did you have something you wanted to jump in on?
Yeah, exactly. To Eric's earlier point, there are many new applications and capabilities that we could leverage Kubernetes. For example, kubeflow, that is based on TensorFlow and kubeflow, empower you develop AI applications on your laptop, switch it to on-prem, or switch to Google Cloud. Seamless experience.
All right. So I want to take a moment of an interstitial here. This is one of the ways you can ask us questions. We did set this Ask Me Anything up as a way to play with the Dory, get your feedback. But there's also for those of you who are in attendance here, there's a networking session that begins at the end of this AMA and will run until 12:30, and that will be over there. There will be, I hear, drinks, coffee, ice cream, fun things. Don't quote me on that. But there will be food and networking. And since the idea of this is getting more access to Googlers, the yellow badges talk to Googlers, give us feedback, give us engagement, talk with us. ask us questions. All right, so on to the next story question. What would be the biggest challenge with AI in the future? Do we start with you, Ja?
I think so.
Talent.
Talent.
Since there are huge demand of AI from very different fields, our education of AI talents are still lag. And there are a lot of competition from different areas and companies as well. We feel it's very important to have more talent in the field. We're thinking about this in a few aspects. One, at Google, we have this internal program to educate talented engineers to learn more about machine learning called Ninja program. And we have turned that into an external program that through Advanced Solution Lab, inviting our customers to send their engineers on-site at Google to learn more about machine learning. On the other hand, right now, of the 21 million developers in the world, only 1 million or so have data science backgrounds, and thousands have machine learning or deep learning expertise. We're thinking deeply in this aspect. That's actually the product philosophy behind our AutoML product. And as we announced 2 days ago in the keynote, we introduced new product family features to AutoML. So till now, we have the capability from understanding image to understanding language and understanding different language from different countries. So AutoML has been empowering over 18,000 customers signed up for AutoML already. Yeah. And since the announcement 2 days ago, we have hit 2.8 thousand customers navigating AutoML from AutoML UI. So we see a huge demand from the field, and we have been happy to see how it has been impacting different industries. For example, from healthcare and life science, we have 10% of AutoML signed up for customers from that particular vertical. And we've seen other verticals like retail, media, entertainment, finance, oil and gas. We hope such product can really help us with the mission of democratizing AI and empowering your business opportunities.
So if AutoML gets good enough, will we not need talent anymore? That would be really good for me.
So that's a very good point, because as you know, in the AI field, we have been making a lot of progress on many of the problems, for example, like supervised learning and end-to-end machine learning, deep learning, data-driven approach. But after working with many enterprise customers, we realized there is a big gap that the technologies who are driving the AI development doesn't know much about enterprise industries, and the enterprise industry customers also lack understanding about the AI technology, and as a result, there are so many new problems or novel problems that hasn't been paid enough attention to by the AI community. And we hope down the road there are more and more innovation in the field, and all the talented deep learning or AI technologists can help advance the other interesting and novel problems that could empower the enterprise industries.
So you need talent to improve the experience for the people who don't necessarily have deep talent. I think that Ja just needs that.
Oh.
Her microphone is very quiet, so.
Oh, okay.
So go, Kelsey.
I think at some point, a lot of this AI is going to have to move into the applied realm. For example, the output of all of this in-mail for most people, if you're building an application and you need to figure out if the user is angry, that has to become a library that you import. We can't expect everyone in the world to figure out or amass all of this data, build models from scratch. At some point, just like your TLS libraries, your HTTP libraries, MySQL libraries, this stuff needs to be imported into your application and be as easy to use as a function call. Yeah. When it gets to that point, I think that's when it's going to be a thing. So the biggest challenge is going to be pragmatism and being applied in the real world. And right now, maybe companies like Adobe can do this inside of Photoshop, but it needs to be something that the average developer can look at and say, oh, there's a set of libraries, maybe a standard library somewhere, where I can bring this stuff in and then enhance my application as just another feature set versus it being this from scratch data analytics project going all the way up to the top.
Yeah. Excellent. So our next question, I'm going to broaden it a little bit. The question is, how will we manage security and permissions in a hybrid cloud environment? But I think there's a broader discussion of security in a hybrid cloud environment that could be had here, because we have different needs in different areas, different needs in different environments, and then we need a way as an operator or as an enterprise to make sure that we have transparency with how these are applied across the different environments. So does anyone want to jump in with?
I'm going to start because people keep saying this hybrid thing and it causes confusion. What is hybrid? Why is this like some special case?
Yeah.
There's two places where you put stuff. You connect them with networks. You store data. All of this is kind of a global thing. So usually you have some global identity. The problem is most people don't have a way to represent a global identity. You got Active Directory on-prem, the cloud provider's giving you AIM, IAM, and then you're trying to stitch them together. So at some point down the road, if I'm Kelsey Hightower, I am Kelsey Hightower everywhere. You have to be able to articulate what can Kelsey Hightower do here and there. Why is there a difference? Like, oh, this is enterprise, Kelsey's now a different person. That makes zero sense. So you can do it by using Active Directory and syncing with IAM. So just like we used to do at LDAP, you have a username, and this user has these roles, and you can reflect those into IAM. We do not need to turn this into a mystery. There are pragmatic, technical things you can do to establish a consistent identity, and then separate identity from your applications. Your app wants to do something. If it's a database, you give it credentials. There's no different way of thinking about this between the cloud and on-prem. So I'm not sure why people have made this such a moving target. Just establish identity, pick something, make it authoritative, and sync it to two places, and then you can move on.
Brad may have some opinions, having done OpenID work.
Yeah, I mean, I was also sold into this vision that you have one identity that works everywhere, but back when I started that, we didn't have like Let's Encrypt wasn't available then, and so everyone just pushed back on, oh, you can't use HTTPS, and I was kind of in that camp too because just nobody would do it. So we used plain HTTP, and then all the enterprises were like, well, that's crap. You can't use plain HTTP, and we're like, well, we know it's crap, but like it's the only thing people will deploy. So it kind of like OpenID kind of went in a different direction than I had kind of originally envisioned. It became more of like an enterprise-y thing that like they just use inside of an enterprise, more like people use like Active Directory or something now. So that vision was never really fulfilled. But yeah, I totally agree that we need something that works everywhere.
I think there's a path that's fairly clear for how Kubernetes helps here that kind of assumes you're already defining hybrid around Kubernetes, which I will be biased to say is my preferred approach. But there's a lot to learn from Kubernetes about how we want to think about hybrid security in general. And the first thing to learn, of course, is that it's declarative, and you should kind of declare what policies you want and then be able to enforce those policies at all the places that matter. So we see pieces of that now. You can see some of that with Istio. Istio allows you to deploy common networking policies on-prem and in multiple clouds, right? You have to use it as your mechanism to get that consistency, but that certainly is working now. The RBAC rules give you access control in core Kubernetes. You have to translate your IDs from Active Directory or whatever to get those to be in the right format. But again, once they are, then you have a consistent approach that works quite broadly. And so I think this combination of trying to get to consistency and trying to get things to be much more declarative and say what you mean, say what you intend as your policy, that's not a trivial transition, and it's going to take many years, honestly, to get it fully developed. But that is the right direction, and I think it's important that you can already start down that path now. I would also add that when we think about managing multiple clusters, there's a lot you can do to improve availability and consistency by treating upgrades as something you do a cluster at a time. So a lot of the tools you'll see for GKE on-prem will take a change, deploy it on one cluster, then the next, and the next, so that you can safely roll out complicated changes, including policy changes, and actually know that, watch how it goes, get canary-like behaviors. So all of that kind of tooling and things we've been doing for high availability in general should apply to policy and security also, and you'll definitely see that coming.
Well, this also speaks to the fact that a lot of what we have in change coming is cultural change, acceptance of new paradigms, patterning of the new paradigms to match what you're used to, understanding how they work together, and then moving forward.
There's one other point I think is worth making. It's a little bit subtle, which is that the reason I like Istio is not the reason you usually hear. And the reason is that it takes policy implementation out of the source code of your microservice and puts it essentially into the Envoy proxy. That sounds like a small change, but it's actually a very big change. And the reason it's a big change is it means that if you separate operations and development, and operations says, I want to enforce certain policies and I want to change a policy, they can now change that policy through the Istio layer without changing any of the deployed services, and in particular without negotiating with developers about what should go in their source code in order to implement the new policy, right? I don't want to have that discussion at all, right? It historically doesn't go well. It's a source of friction, and it slows down developers, and it makes central IT the bad guys.
And to be clear, though, I think people have to understand the point of Istio, it provides a framework to wrap your mind around. I've seen people do this with libraries, where there's someone that builds an application tier set of libraries that maybe you don't want to use the service mesh, and you can implement some of this policy, because there's still some, there's off-in, like who you are, and off-Z of what you can do, and sometimes the developer will have to influence the details about what you can access in the database that you may not be able to do from outside. But the whole goal is write down the policy. If you're confused, jump on the whiteboard. If you have to start with the question mark, that's a better starting point than saying things like hybrid, distributed, authentic. Just write it down. I think you're going to arrive to the solution.
Yeah. Awesome. Thanks. So we have another question, and this may be our last question, depending on how we keep talking, but we have been having fun discussions. So a question from Nicola from Intel. How have containers changed how you design your data center infrastructure? And I think that's kind of a hard question for Googlers to answer, since we've been using containers a lot longer than containers have been popular. Google actually wrote a lot of the early work in the Linux kernel to allow it to be containerized. So does anyone have early days?
I don't think it changes much right now. Most people, it's like the customers that I work with, when I go on site, and some customers or community members like GitHub, for example, that have been running their own bare metal, and there's other customers of GCP that also have on-premise stuff. Most people are not necessarily changing the entire underlying layer. Some people are just installing Kubernetes on top of VMs or on top of OpenStack. More advanced users may be PXE booting a Linux distro, but again, they're still installing Kubernetes as a layer on top. Most people haven't really harvested the ability to think about bin packing at a very large scale, where they start doing things like Google does, turning machines off at certain optimal times of day, and trusting and relying on the ability to move a container around. A lot has to happen before I think people revamp data center design. And lastly, I think a lot of people are buying off the shelf. Cisco switch, NetApp, NFS device, something from HP, and honestly, those just have pretty obvious design patterns. You're going to glue them together in a certain way. So I think most people are just going to follow a very common pattern, rack stack, and then throw Kubernetes on top, not necessarily re-architect the way they think about hardware.
That's sort of phase 3.
What's that?
I said that's sort of phase 3 of adoption.
Well, I mean, maybe when phase 3 comes, is that not just this distributed cloud thing? So we talked about GKE on-prem. Is it that one day that there's going to be a magical box that shows up and really extends this fabric across everything before you yourself or every vendor in the industry redesigns how their hardware works together? I think that's probably an interesting trend to think about.
Anyone else want to cover data centers?
I guess I would say it's worth taking a step back. Historically, before Google, I had a company long ago called Inktomi that built a lot of essentially what you would say is container-based workloads. Although at the time, it's really, instead of Docker file, it's tar file. And instead of Linux support for containers, it's just plain old Linux processes without much isolation. But at the time, these were single tenant workloads, and that was good enough. But this is, mid-90s. And so the way you would build infrastructure in the mid-90s is based on Unix processes, right? And it wasn't always even Linux. It was actually more likely to be Solaris at the time. But absolutely, it was Unix. And had many of the same things, like you do compiles, you deploy binaries, you have libraries, you link for certain policies. So in some ways, that feels more like Kubernetes than the intervening 20 years, which was really about, let's use a virtual machine, we can move our workloads on the virtual machine, we can get some utilization savings for that, but it meant that the infrastructure was about the VM and not about the Unix process. And that, I think, was an important historical transition to get people into cloud, right, and into efficient use of servers. But honestly, the Unix process model was more productive and had less stuff to manage. And we're in some ways returning to that with Kubernetes and saying, I really just want to focus on my processes and my APIs and services, and that's where I get my productivity. And the VMs are still there, but they're a little more hidden, right?
And the layover from that is the networking model. So most people that do have segmented VMs and virtual machines, you see all these VLANs creating network segmentation instead of the world that Kubernetes sees, which is a flat network model using policy to deal with the security versus these hard paths and walls between the different machines.
I think the difference is now we have the tooling and a variety of security boundaries that allows us to go back to the process model and actually make it work and get the full productivity.
Well, this also, with the tooling, it democratizes it. You don't have to know the finer workings and the inner bits of the kernel to make that work in a very specific workload.
And by the way, because Google started pre-98, they didn't use VMs either. And so all the internal infrastructure on Google uses almost no VMs. It's all based on containers on bare metal. And it's essentially the process model also.
Yeah. OK, so we are getting questions from the audience, which makes me happy. So let's do at least one more. Here's a question from Kevin. What keeps you all up at night hoping to be more automated in the cloud?
More automated.
Brad, do you have opinions?
Like I said earlier, I'm just happy that I can push a container now and run it.
Yeah.
And I'm not dependent, on one cloud provider, and I'm not dependent on using somebody's APIs. Like I used to be really excited about App Engine Standard when it first came out because it was kind of like what I was used to inside Google.
Right.
That was now kind of open, but not really open. Like I can use it for personal projects, but like I worried about it going away, or I worried about growing outside that little box and having to do something different.
Yeah, the
and so
constraints
my love for App Engine Standard kind of like faded over time. And then now that it's getting all this love again, and I can just give it a container and pay as I go, I love that.
Yeah.
So mine really quickly is the thing that keeps me up at night is too many layers of abstraction. This is getting unwieldy. So if you try to troubleshoot all these things installed at once, it is a lot of layers, and most people haven't really learned the base principles. And this is why when I talk about things, I always talk about the lowest common denominator base principle and moved up from there. And a lot of people don't understand. We're going through a reset now where most people won't understand the base principles, and we're bringing in this stuff wholesale. And when you have that first outage, you're going to realize what the cost is of all these layers of abstraction.
No, you're absolutely right. A lot of SREs, I think the super valuable skill that we don't talk about is that they can see the entire vertical stack, which is just crazy. That's what it means to be an SRE in practice.
It also means the time to iterate during development is often painful if you have to wait 40 seconds for this and 20 seconds for this. And then I just want to be able to like write some code, hit up enter, and like see it working in the cloud. So anything that removes these abstraction layers often improves latency. It's kind of a side effect.
Totally. I hope we could automate machine learning development, because right now machine learning development is an extremely complex cycle. You need to collect data, get insights in your data, design model, tuning your models, and updating it and iterating. Every step would require a lot of machine learning expertise. We made the first step as AutoML. Right now, it understands image, text, and language, but we hope to expand it to more areas. For example, like speech, how do we understand audio, and how do we understand unstructured data. And also, there are a lot of more sophisticated problems from the industries that require almost end-to-end solutions. We offered one new product that is the contact center AI as the first step, but I believe there are more problems that would require both ease of use as well as sophisticated solution. I hope we could contribute more to that.
Well, thank you to all my panelists. Thank you to all of you in the audience who contributed questions. And I hope you will join us for the networking session. As I said, everyone having a yellow badge is a Googler who has been properly primed to talk to customers, end users, engaged with people, listen to your feedback, because feedback really is a gift. That is one of the best things you can give us and one of the best things we can get out of this conference. So thank you. Enjoy the rest of the day here at Next, and I hope to chat with you in the networking session. Thanks.
welcome Group Manager, Google Cloud Ops and SRE Products, Mark Carter.
Hello, San Francisco. Give me a hello. Hello. Okay, so it's been an amazing week, and hopefully you still have energy for some more cool stuff, because we have one more cool announcement for you, and we have some Google magic in the demos. In Google, we put customers front and center. We care deeply for the experience we provide, and we've been in a journey for the last 15 years building planet-scale services. By doing that, we learned a few things. We learned that experience is driven by providing performance, reliability, availability. And in order to provide those things, we developed a culture which we call site reliability engineering. And site reliability engineering is a combination of people, which is all of you and many of us, practices, which we'll talk a little bit about, and products that we are making available to you as part of Google Cloud. So we have cool demos. We even have very interesting giveaways at the end, so I recommend staying. And to move to the exciting stuff, there's nobody better to tell you more about that than the person that branded and created site reliability engineering. The person that his LinkedIn profile simply says, if Google stops working, it's probably my fault. Ladies and gentlemen, please join me in welcoming the VP of Google 24/7, Ben Traynor.
Thank you, Mark. So thank you all for joining today. I want to talk a bit about a new product announcement that we've got, which is the launch of the Transparent Cloud API. And to do that announcement, instead of talking at you myself about how cool it is and all of the things we expose, I actually want to introduce someone more qualified than myself to talk about how useful this is. Lingwen from Snapchat, please join me. And have the tipper. So, Lingwen, we all know that Snapchat was an incredibly popular application during the FIFA World Cup 2018. Things were happening fast. People were sending snaps using their cool Snapchat spectacles, excuse me. And we also know that the load was incredibly high. It was one of the most popular events ever. How did Snapchat keep everything so snappy, right? During the event, how did you guys end up stealing the show like that? Please, speak into the spectacles and tell me.
All right. Thanks, Ben. Hi, everyone. I'm Ling Yun, and Snap engineer. So Snapchat is the best camera to share the moment with friends. During the World Cup, there were traffic spikes or backend after each important goal, which means users were sharing their excitement at this exact moment by sending snaps or posting stories with our top-class lenses. Publishers also created a lot of World Cup-related stories for users. We really want our users to have the best product experience on Snapchat. Thus, we need a strong serving infrastructure that achieves high availability and low latency. So to optimize the serving for different types of stories, we have this complicated backend, which consists of a great number of components. Each component can depend on multiple cloud services. To run a complicated system like this well, we need good monitoring to understand its performance. We also want to discover and root cause issues fast. But this is especially challenging if you run your service on the cloud, because often you will rely on these cloud products, which are usually black boxes in monitoring world. Let's simplify the problem. So if we take away all the implementation details, we'll see some simple diagram like this. There are three parts in the system: client, our services, and the cloud products. Just like what people usually do in the cloud world, our services rely on these cloud products to serve requests from client. And we try to make the best use of these cloud products so we can focus on the implementation of our own business logic. We wouldn't spend effort reinventing the wheels as long as these cloud products can meet our service quality requirements and are also cost efficient. To tell whether the whole system is running well, we would add monitoring in different places. So first, we need to understand the overall healthiness of this system. So we usually add serving metrics, including traffic, errors, and latency to our service. These metrics are direct service level indicators that tell us how well the system is running. And we also set up alerts on these metrics, so we can get a notification when the serving quality degrades. During an outage, we want to know which part of the system is broken. And a service can have multiple internal components. It can also depend on other services. For these internal components, we can add custom metrics to measure their performance directly and tell which part goes wrong. What about these outgoing dependencies? So people usually add client-side metrics to measure the errors and the latency for the requests that go to a dependent service. These client-side metrics are helpful. They are strong signals to indicate whether we are having issue calling a dependent server. But the problem is, they don't tell us where the issue lies. The issue can locate either on the caller side or the dependent service side, or it can be network issue in the middle. Thus, people usually want to check the serving metrics of this dependent service, so they can compare them with the client-side ones. And only through this kind of comparison, we can get a better picture of what is going on. If we're on the dependent service, we can get these metrics easily by either adding instrumentation or just installing a monitor agent to collect these metrics if they are already available. But what if the dependent service is a cloud product? In the traditional cloud world, we can't get the serving metrics of these products. But now Google is offering this visibility to its customers under this transparent SLI effort. So let's walk through a real use case to see how these transparent SLI metrics are helping us with production debugging. So let me use this simple service as an example. So this is one of the subcomponents of the complicated story service backend, which is shown in previous slide. And this service is one of our story services that serves stories metadata in search result. So when users type something in the search bar, to reduce the search response size, we don't include the full metadata of these stories immediately. The client will only send a request to fetch the full metadata of the story, only when user clicks on a story. And we store these stories full metadata in Cloud Spanner. And we built this simple serving layer and deploy it on GKE. So this service just translates the request from client side into Spanner queries and execute the queries on Spanner, and then returns the result back to the client. Very straightforward, right? Then let's discuss how we are going to build a dashboard to monitor this simple serving stack. So the most important question we want to answer in this case is this story service performing well? Thus, we added the serving metrics in our first row. From left to right, these charts are requests and errors, error ratio, average latency, and 99th percentile latency. These are all well-known SRE golden signals. We can get a good sense of the service level with just a single glance at this row. As this service is just a thin wrapper of Spanner, so when there is a production issue, the first thing we want to check is whether these Spanner requests are doing OK. So heuristically, we added this Spanner client-side metrics at the second row. In the past, if we did see something from these two rows, we would start to guess. Maybe Spanner is having an issue, but we could not be 100% sure about it because these client-side metrics don't tell us the full picture. And it's in an outage, our users are impacted, and we really want to mitigate the problem as soon as possible. And we wish we can see directly behind the curtain and shorten this procedure of verifying different hypotheses. Luckily, Google.
You don't want to hear that.
Yeah, I don't want to hear it right now.
I don't think we have to hear that yet. Let's keep looking at this issue on the dashboard that you've got.
OK. So luckily, Google now is offering us this visibility. So we can put this Spanner transparent SLI metrics on the third row. These metrics are direct Google side performance indicators of how well Spanner is handling requests from this particular Snap service. We'll see example soon how this metrics can help us locate issue fast. The rest rows are resource metrics. We always want to make sure resources are provisioned properly. In the fourth row, we have the charts to show Spanner resource metrics, and including per table Spanner instance CPU utilization, and per table operation rate and errors. In the last row, we have the charts to monitor our services resource. And from left to right, these charts are per instance CPU utilization, memory utilization, and network traffic. So in all, having a dashboard with these 5 rows, we can answer the question, is it a Snap issue or a Google issue faster during an incident? Just a side note here, Google exposed the dashboard API, so we can configure a dashboard like this using code and keep track of all the changes in our code base. This feature is currently under early access program, and we really enjoy it. All right.
Uh-oh. Lingwen, there's that sound again. I think something might actually be wrong. What are you going to do about it?
Yeah, let me check the page. Don't panic. Let's check the page. Oh, OK. It says our server ratio has jumped significantly for this storage service. Don't panic. Let's open the dashboard and take a look. So now we are looking at the dashboard we just built together, right? So remember, in the old days, we would start from this, the first set of rows. And let's see. In the first row, our three metrics, we can see the error ratio has jumped with latency, which is a common scenario in a production outage. And it usually indicates either the processing on the server side is slow or there's some slow backends. And the number of errors started to climb as requests started to timeout. And then let's look at the second row, our Spanner client metrics. And we can see these charts align very well with this in the first row. Then it seems Spanner requests are taking longer to return. Is it a Google issue? Usually at this stage, we will file a support ticket to check with the support engineers. But now we don't have to. Now we can look directly at the third row, this Spanner transparent SI metrics. And let's see, it says no errors. And we can also see some latency increase. But if we take a closer look and compare the numbers with the numbers in the first rows, we can find something interesting. Client latency increased 10 times more than what the server side shows. So it implies maybe it's not an issue on Spanner side. And the Spanner side latency increase can be a result of slow client reads. So at this stage, let's continue investigating on the Snap side instead of filing a ticket. So let's look further down in the dashboard. From this Spanner resource metrics, we can see our Spanner instance actually are running with reasonable CPU utilization, which is another signal that doesn't support it's a Spanner side issue. And then we move on to this resource metrics of our service. Here we go. We found when the instance took place, the CPU utilization of one of the server instance jumped to something crazy, like 100% utilized, while the CPU utilization for other instances dropped. It usually indicates the traffic is not balanced, and one single instance is serving almost all the traffic, which is pretty bad. And we checked around and found someone just made a bad load balancer configuration change. So let's just fix it with a revert. So we've just gone through an example of how we're using different metrics to root cause a production issue. This can be just one possible version of the story in which this transparent SI metrics helped us conclude it's a Snap side issue. And we saved a lot of time by not creating a false alarm ticket to Google. As you may know, communicating over the support ticket is very time-consuming, even if the support engineers are very responsive. This is because support engineers need to understand your service, your environment, and your issue before they can start investigation on their side. And it takes a lot of back and forth communication for this cold start. The whole story can be a different one if when we look at the Spanner SI metrics and found it's a Google side issue. In that case, we can just create a ticket and point the support engineers to the exact metrics metrics we looked at, which also makes the communication faster. So as a summary, we really like these transparent SI metrics as they give us additional useful visibility and also help us save time in production debugging, no matter it is a Google issue or not. All right, thanks for listening to our story. Let me hand it over back to Ben.
Thank you, Lingwen. So yes, as Lingwen has just illustrated, this sort of scenario actually happens every day in production, right? Things work differently, you have variations, and one of your first jobs, especially if you have that klaxon going off in the background, is to figure out what has occurred, right? Something has changed, but was it a user behavior? Was it a push that you made? Is something going on the platform? Historically, the way that this would get done is you would look at your application and then file a ticket, and 20 minutes later, somebody from support would get back to you, and you'd joint debug, and all this time is passing, and your users are being damaged. And if you can make those intervals shorter, if you can make the period between when the klaxon goes off and when your service is working normal again much, much shorter, all of your users are happier, and your engineers are more quickly able to solve the problems that they are introducing, either intentionally or otherwise, with the changes that they're making. And so this introduction of the transparent SLI and the transparent API for all of Google services is a huge step in that direction. It lets engineers at companies like Snapchat spend more of their time developing and rolling out cool apps and less time debugging problems. So I'm happy to announce today that the transparent SLIs are available for all Google services, and they give you the same key signals that we actually have learned to use internally at Google in the site reliability team to manage all of Google's infrastructures. Thank you. This both, from my perspective, helps everyone develop and keep running their favorite services on Google, and it helps us apply a little bit of what we've learned over the last 15 years of running Google's internal cloud and make it easy for all of you to develop your applications. And it helps you minimize the time between when something unexpected occurs and when you've accurately done a differential diagnosis and have either said this is something that we can change on our own or we need to contact Google. And if you do contact Google, you can send the screenshot that your application monitoring has sped up, and we won't spend any time trying to figure out what's going on. We can dive right to the heart of the issue. Finally, even in developing applications, when nothing is going wrong, it's very useful to be able to see details of what the backend services are doing, not just the median latency or the error rate, but actually the latency distribution and what happens over the course of the last week. And this lets you build applications that are better suited to the performance characteristics of the infrastructure that you're running on. If you would like to learn more about this and other cool production development practices, we have access today in Stackdriver, and we also have access today through our partner Datadog, who takes a lot of this to the next level and gives you integrated dashboards and value-added services. And we have the Fifth Nine, which is the site reliability and customer reliability engineering lounge, is open today until mid-afternoon. And if you come by and visit, not only will you be able to talk to SREs and CREs, but we have free copies of our launch edition of the second volume of the SRE book, which I highly recommend with no bias at all. And you'll be able to talk to people and maybe even get your book signed. So Lingwen, thank you for showing us how you will use this service. Thank you all for attending the launch of this. And I want to now introduce Morgan, who has another announcement for you.
Thank you. Hello, everybody. Thank you for coming. I'm going to do a demonstration today of our Stackdriver APM tools. So for those of you who happened to watch the keynote this morning or part of the keynote on Tuesday, we made reference to these. In fact, this morning we did a live demo. And so our APM suite is aimed at developers first and foremost. So our APM suite includes Stackdriver Trace, which allows you to view how requests propagate through your application. Stackdriver Debugger, which allows you to do breakpoint-style debugging safely in production. And Stackdriver Profiler, which is our newest addition. It's a continuous production profiler that allows you to see how your code actually executes while it's running. So rather than do a presentation or a deck, I'm just going to do a live demo. Part of this was captured in this morning's keynote, but part of it also, the debugger part, is new. And so I'm really excited to show it to you. So if we could switch the screen to my laptop. Perfect. So this is Hipster Shop. If you've gone to any of the keynotes, you're probably already familiar with it. It's a demo application that's composed of, I think, 7 or 8 services, some of which are written in Go, some of which are written in Python, Node.js, and finally .NET Core. We've gone and instrumented it so that it works with Stackdriver, and it's running on Google Kubernetes Engine. This version is not using Istio like the version on the Tuesday demo, not that that really makes a difference. Also, unlike the version on Tuesday, this version is incredibly slow. We're very happy it wasn't like this during the Tuesday presentation, but we've gone and slowed it down so we can find out why. And so, I clicked on Vintage Typewriter. It takes a while to come up. I click on Add to Cart. A lot of these interactions exhibit very, very poor performance. And because it appears to be just all these general interactions are slow, things like application level metrics, like latency metrics for a particular service, aren't going to be especially useful. Because with our strongly interconnected web of services, a slowdown in one is going to cause slowdowns in all of them. What we can use, though, is distributed tracing. And distributed tracing allows you to track how a request propagates between different parts of your application as they actually happen. So this scatter plot here on the vertical axis shows the latency of captured requests. On the horizontal axis, we have the time at which they were captured. And you can click between them to view the different traces. And when you click on one, you see what we call the waterfall graph. This waterfall graph shows the different components of a request. So in this case, it's the different services that it hopped between as the trace was captured. And so from here, we can see that this was a call made to the cart endpoint of the front-end service. And then it went to the currency service and recommendations, and finally it started going to product catalog service. Now we see 2 things are a problem here, and we went over this in this morning's keynote. The first is that we're making a ton of separate requests to product catalog service. This just seems like bad design, right? Like if we're viewing a set of data for a particular product or looking at something for the cart, we should probably be calling the catalog a single batched request if there's multiple products. And if there's only one product, we should really only be calling it once. That's going to take a while to fix. Like there's some real re-engineering there, and I'm not going to bore you to tears with a demo while I rewrite the application. But the other thing that we can investigate is why these individual requests are slow. So even if we batch these up, this would take still far too long. Our trace that had, 10 seconds of latency would still have well over 1 second if we batch together these product catalog requests. You can see this individual component is already 1.5 seconds long. And so the trace doesn't help us go any deeper than that. Right? You can add custom components to the trace using our APIs, but still, generally, you want to understand how the code is actually running. And so to do that, we can jump to Stackdriver Profiler. Stackdriver Profiler is a continuous production profiler. It's the newest component of our APM suite. And it actually, to you as a developer, you basically turn it on your application and forget about it. And it continually captures information about how your code actually executes in production. The nice thing about Stackdriver Profiler is that compared to sort of similar entries in the market, it has effectively no performance impact. So you can just leave it running. In the background, will sample itself. It'll turn on and off on various services at different times. And to you as a developer, there's basically no performance cost, which is why it's really nice. And you don't have to worry about it. You don't have to turn it on. You don't have to start profiling sessions or end them. It supports heap, thread profiling, and CPU profiling, depending on the language that you're on. It'll also do wall time profiling. We're going to jump into CPU profiling, and we can see something right away. The get product endpoint of this service, the gRPC method for it, is really, really slow. It's consuming 92% of our system CPU. If we run a language that allowed wall time profiling, we'd also see that. And we can see that effectively all the time for it is taken up by this parse catalog method. And so what we can do now is dive into the code and see what's actually happening there. So this is the parse catalog code here. This is inside our product catalog service. It's written in Go. And we can see here when it's called, it basically just does some JSON deserialization. And so from going from trace, we understood which service was calling a slowdown for our application. Without distributed tracing, that would have been incredibly difficult. And now with Profiler, we found the actual function in our code that's slowing everything down. So in just a few minutes or a few seconds, depending on how quickly you went through this, we can find out exactly where our slowdown is caused. And this might seem like a bit of a contrived example. In fact, if you looked at the code, you see that I made this use JSON serializations to slow it down for a demo. But for when we talk to our customers, this isn't so outlandish, right? We've talked to many customers where their services are slow because they are just burning CPU time on serialization, deserialization, or where they have things like regular expressions or just functions that you wouldn't even expect to show up as a blip on a CPU chart or really a list of things that are slowing things down. And it's consuming 10, 20, 30% of their system CPU. And so this is actually an example that's really, really appropriate for things that our customers have run into. And so in the demo this morning that I did at the keynote, we then redeployed the service and fixed the issue. I'm not going to do that here and repeat everything. What I will show you is that between the different versions of this code, we can compare their performance with the new Stackdriver Profiler comparison feature. And Stackdriver Profiler comparisons allows you to compare profiles from your services either across versions, across different time periods, or across different regions. And from this, we can see that the slow code here, particularly parse catalog, has gone to effectively 0% CPU. And even the get product endpoint, which of course is still there in the new version, is now down to effectively 0% CPU. And we can use this to verify that our code changes had the impact that we expected. Obviously, if you were doing this in real life, you'd want to start by doing the metrics comparison of latency just to verify that your changes have worked. But with this, we know that the changes inside the code have actually had the effect that we wanted. For Stackdriver Trace, we also have a similar feature where you can compare latency across time or across versions or across different areas. So I mentioned that Stackdriver APM is composed of 3 products. So I mentioned Stackdriver Trace. I walked you through Stackdriver Profiler. Finally, Stackdriver Debugger. Stackdriver Debugger, just like the other tools, you can run safely and continuously in production. It is very sort of magical in a sense. It lets you set breakpoints in your production environment safely. We call these snapshots. And so the best way to show this is just to give a demonstration. So the code I'm looking at here is for the currency conversion service. This is a service where you can call in, give it a value in US dollars, and tell it, I want to know what this is worth in euros. The Hipster Shop store lets you change currencies. The currency service is what performs this. So one of the challenges that you might have with the currency conversion service is that it might be converting currencies in a different manner than you expect, or it might be converting them with the wrong values. So the way the service works is every hour or so, it goes to a web service, I think hosted by the European Central Bank or something like that, that lists their up-to-date currency conversion rates. So let's imagine that you looked at those rates and you looked at the values that the currency conversion service was outputting, and they didn't match. Today, to debug this, you'd probably add a bunch of log statements to the service to print out what it thought the current currency conversion values were. You'd go and redeploy the app, which might take a while depending on your environment, and then you'd see the output of those logs. With Stackdriver Debugger, we can short circuit that. All I have to do is click here on line 123 in the interface. We've already captured a snapshot. There's a load test running against this. And from here, we can look at the local variables, like this data object, and see the actual values that the service thinks in memory that it should be converting these currencies at. So right away, you can debug it and verify if your hypothesis that the currency conversion values were wrong, you can verify if that was correct. We also, just like a traditional debugger, support full conditions, so you can tell it to only set a snapshot if certain variables are set to certain values, and you can use expressions to inspect the output. Finally, you can navigate through the different frames in the call stack. I admit that this is probably not the greatest example because this node function calls itself a lot, but you can also view the variables within those different frames. So it gives you the power that you expect with a regular debugger without halting execution, without interrupting your customer's workflow, which is really, really, really excellent. We use technologies like this, Profiler and Trace, every day at Google, and we're really excited to show these to our customers. So we should talk about 2 things with these. The first question that always comes up is how easy is this to set up? I can tell you from experience, from working on this demo app, as well as just, of course, working on these products a lot, it's very, very straightforward. So we do in-process instrumentation, simply libraries that you link to your application and redeploy it. All of our instrumentation is open source and Apache licensed on GitHub across all languages. For Trace and for Debugger, we support Java, Go, Node.js, .NET, Ruby, Python, PHP. So we have a set of 7 languages. For Trace, we additionally support C++. For Profiler, it's relatively new, so we're still building out the language support. So we support Java, Go, and Node, and we're developing support for Python right now, and then we'll continue looking at the others. For Stackdriver Trace, our instrumentation is through a project that we started at Google and we still run called OpenCensus. OpenCensus is a set of language-specific libraries that will automatically capture traces and application-level metrics from applications. So, for example, in this application here, by adding OpenCensus to one of the Go parts of the application with these lines of code here, we automatically captured traces, propagated context, embedded annotations and attributes in those traces, and we automatically captured application-level metrics. So it's really easy to get started with. We have integrations across all these languages for things like gRPC, various HTTP clients, SQL clients, other storage clients, client libraries for Google, and so on. And we try and make it as automatic as possible. OpenCensus is also great because we have this concept of exporters. And this is the reason OpenCensus is a community project rather than just a Google project. So when you set up OpenCensus, we told it to export to Stackdriver. But if you were using other APM solutions, we mentioned Datadog earlier, you can export to Datadog via OpenCensus, or Prometheus, or Zipkin, or SolarWinds, or others. You can export your data to your backend of choice. And with OpenCensus, you can export your data even to multiple backends at the same time, which is really powerful. So we've made this really easy to get started with. You simply link a few libraries, including OpenCensus, to your application. They'll automatically capture the right telemetry, redeploy your app. You can get started with Stackdriver APM. The pricing on Stackdriver APM is extremely competitive. Debugger and Profiler are currently free. Trace has a pretty generous free tier, and then there's a paid tier after that that goes into effect in September. Compared to competing solutions, it's like a tiny, minuscule fraction of their cost. So with that, I'm done the demo, and we'll move on to the next speaker. Thank you very much.
Apparently, I am back up again. Let's move on. Oh, they send me out here without any instructions. I believe that is actually the end of our presentation, so I want to invite my fellow presenters to come back out, and we are going to take Q&A. I'm guessing mostly because A, that's what we rehearsed, and B, the clicker doesn't work anymore. So thank you all. So come on out. We're going to do Q&A. Special, I realize, Q&A is always hard, and in particular, getting people to ask that first question. Everyone's a little nervous, and we can't see anyway because all these lights are in our eyes. But we have an incentive today. For everybody who asks a question, we have an SRE book with us, which we'll be handing out. I think I'm not going to actually throw them out into the audience because that has a less than 5/9 chance of success, but we have assistance with the book. And for the best question of the afternoon, Lingwen was kind enough to bring along a special set of the Snap spectacles. We'll be judging at the end of this little session amongst ourselves, picking the most insightful or incisive question, both are welcome, and awarding that. So please, don't be shy. If there's anything you ever wanted to ask us, this would be a grand time. Yes, right there. And they will come to you with a microphone because it's being streamed.
This is trivial, but I want a book. I apologize. I missed the language support story for Debugger, and I didn't see it on the web.
Yeah, so Debugger, we've got support for Java, Go, Node.js, Python, PHP, Ruby, and .NET, including .NET Core.
Got it, thank you.
Not bad. Yes. We will trade you a book for the microphone.
Press the button or? Okay. What about obfuscated code, like, when code is obfuscated? So PHP has obfuscation, Java has it. What about that?
This is for Debugger specifically?
Yeah.
Yeah, so for Go, for example, we have a limitation right now that we're actually actively working on to fix, where you actually have to turn off some of the optimizations and obfuscation by default. I think for the other languages it just works, but I don't know that for certain. There's documentation that'll tell you, but I believe Go is the only one that actually you have to do something.
Question back here. So beyond from a technical level with site reliability engineering, can you give one piece of advice from a change management culture perspective that you would recommend from people-wise, operationally, that folks can do to start taking that transition in?
Oh, heavens. Yes, actually, the single biggest piece of advice that I can offer is that usually in any organization that has a set of folks who develop features and another set of folks who make sure those features work in production, they don't actually have the same goals. And as an executive, you can say, please have the same goals. We all want what's best for the company. That doesn't matter, right? Nobody listens to that. At the end of the day, right, they're sort of focused on what are their goals for this quarter, and the other things that they do are roughly out of the goodness of their heart, which means the more stressed and overworked they get, the less they're going to do on it. And so the core for making the SRE developer relationship work is to fix the way that both groups are operating so that they do, in fact, in practice, have the same incentive. And so though that will vary from company to company, the most common example is to introduce error budgets as a way of deciding whether features can launch or not. And if you're not familiar with error budgets, it's explained in detail in the book, but the basic idea is you decide how available the service should be, and as long as the service in practice has been that available, the developers can launch features, and as soon as it hasn't been that available, they stop launching all features. And this is a very simple sort of on-off control mechanism, but it quickly helps everyone realize that the name of the game is to make the product reliable enough that it never blows its error budget, it never goes out of SLO, and that in turn guides both teams towards the next logical goal, which is how do we fix all the places where the product seems to be breaking either during runtime or when we're launching new features so that we can safely launch features so we don't keep blowing the error budget, which is actually something both teams can agree on and work separately towards. But if you want a more detailed version, we have about 1,000 pages of a book between the two volumes, and it is, I think it's entertaining reading, I'm biased again, but it goes through sort of the 15 years of development that we've had so far, both in the theory, which is book 1, and in the practice and application, which is book 2. And I think you'll sort of see a number of the pieces in those books that apply to almost any developer operations situation that you're in. Great question. Yes.
So my organization is actually migrating a number of applications and services over to GCP. We're investing heavily in that area, but we're going to be in a Frankenstein model for a number of years. Maybe I'll call it a hybrid cloud environment.
We prefer the term hybrid, yes.
Oh, there you go. So will we be able to leverage Stackdriver and these tools in this environment, being able to dig into the different backend systems and the stacks and flows that we have?
Yeah, so I can answer that. Stackdriver APM, so the stuff that I demoed, works on applications running anywhere. It's like when we were building this, I had to just instrumenting stuff on my laptop. Our monitoring and logging tools right now have some level of dependencies on GCP and AWS. I know that we're actively working to allow it to run on-prem or on other clouds outside of those two.
Question here. Hi. What's your recommendation for automating all these kind of metric and dashboard buildings? Because over time, we have to build like over 200 projects in our GCP environment, and the metrics and all these alerts are at the project level. So what's your recommendation for automating all these alerts and dashboard building and all this automated monitoring tooling?
I'll take it. It's an outstanding question. In Google, we believe in automation. Like any things that humans shouldn't be involved, we continuously try to get them out of the way. So I completely resonate with what you're asking. Today in Stackdriver, we have an API to automatically set up dashboards. I can follow up with you offline and point you to the recommendation. But you'll be able to completely define all the alerts, dashboards, and set them up so when you create a new project in GCP, all the right stuff gets created. Internally in Google, we have been doing for a long time, when you publish a new service, you get a set of automated capabilities, and we will be announcing some additional cool stuff later in the year, so come meet us in London and I'll have more cool stuff for you.
Yeah. So what are the key challenges you have experienced when adopting a SRE model in a regulated industry?
Ben?
I mean, I think, so there's the obvious one which crops up, which is that many regulated industries have restrictions on who is allowed to have privileged access. It hasn't typically, for the customers that we worked with, it hasn't been an issue per se because they already had employees who were using a more standard operations model typically, right, who had the same restrictions. And so you simply end up adopting new set of practices, same set of organizational structure. We've certainly had questions which are not specific to the SRE model, right? For a given regulated industry, who has the ability to actually look at what sorts of data under what conditions? But I don't think those are at all particular to sort of the SRE model versus a non-SRE model. And then finally, the class of questions I've seen come up is around SLAs, right? So this industry requires, for example, that we have 10 kilometers between where two instances of a set of data are being stored, and we want to make sure that if you have practices, those practices don't ever involve moving data, too many copies of the data closer than that. Can you sort of go into more depth about how the SRE practices work? And those end up actually being product questions, right? You have to have a product that basically enforces the rules on things like data locality that are part of the regulation. But I would say generally, if you say that SRE is sort of a subset of all the ways that one could do operations and in its integration with development, there isn't really much that crops up that's idiosyncratic for SRE.
Thank you.
All right. Piggybacking on the question before from over here. So when you're running your applications, you have a bunch of projects. It is possible to set up projects for exporting logs and APM data specifically for Stackdriver, right? So I may have an app and it's running in my dev, staging, and production project, but then I can create Stackdriver specific projects for that type of data, right? Is that a possibility?
Yeah. So certainly, I work on APM, so I can't speak as much for monitoring and logging from experience, but certainly for APM, you can redirect the data to whatever project you want. There's a bit of work involved in that, like a small amount, you just have to configure it, and it won't be automatic. But for APM, you can do that. For monitoring, monitoring uses a bit of a different sort of scopes. And so monitoring has this concept of accounts or workspaces, and you can use that to aggregate data from multiple projects at once.
Thank you.
My question is regarding the Stackdriver. Is this tightly coupled with GCP, or do you have any plan to open source it or make it available for other cloud providers?
That's a great question. I think in Google, we are passionate first-class open source people. We would like to contribute and collaborate because open source makes us better and it makes the community better. There are areas, there's a lot of areas in Stackdriver that are open source today. So we use open source agent, FluentD and Collecti, and we help maintain them. Morgan talked about Open Census, which is a project that Google started, but the entire community is joining. The areas that we are not open sourcing, because simply, even if we would, it wouldn't be practical, is the backend platforms that Stackdriver sits on. Stackdriver sits on the time series and log database that serves Google itself, and as you can imagine, that's massive. Unless you have a few 100,000 servers lying around, I don't think that open sourcing would help. From a UI standpoint, the UI experience and the experiences we build, we try to work with open source projects that you will have an equivalent, so you can run the same everywhere, but if you run on Google Cloud, you remove the need for you to maintain it by yourself. So a great example is our partnership with Prometheus. Prometheus is tightly integrated to the Stackdriver Kubernetes monitoring. So if you run anywhere other than Google Cloud, you can just use Prometheus. If you run on Google Cloud, Prometheus seamlessly integrates with Stackdriver, and many of the Prometheus contributors and maintainers are part of our team.
My name is Manling. So I'm wondering, for debugger to work, do you need to check in your code into Google repository?
Yes, that's a good question. I know where you're going with it.
And the second one is do you need to compile your code in a spatial way?
So I'll answer those in order. So I showed you the code in the IDE-like interface. So you can pull in that code from GitHub, GitHub Enterprise, Bitbucket, GitLab, or cloud source repositories, and you just do that by just OAuth. And that's all done through client side, so you're actually not sharing your code with Google, not that it might matter to you or not. If you're not using any of those, you can also just bring in your code locally. So there's an option just to visualize your code from a folder on your computer. If you can't do any of those for some reason, you can always just, in the UI, just type in a file name and line number to debug. So the code is just pulled in for visual elements. And your second question, I think, was about compilation. Yeah, and I think this actually harkens back to one of the second question that we got, where for Go, you need to turn off a few optimizations, and we're trying to fix that, it's just not there yet. For most languages, no. The only thing you need to do is link a library to your application, instantiate the library, and then forget about it.
In the use of APM, if I have a complex multi-tiered application, what's the best way for me to leverage APM to identify what level in my service stack the issues are occurring in?
Yeah, so like that's what Stackdriver Trace excels at and distributed tracing in general. So just like the demo I walked through, when you have an application that's being slow, you might not know the cause, right? You might have hypotheses about, oh, I think every service is slow because we're using some library that's slowing things down, or I think it's this one part of the application. And with metrics, for example, even service level metrics about latency, because those services are interconnected, you might not be able to tell which one's actually the cause of the slowdown. With distributed tracing, like Stackdriver Trace, you can actually walk through that sort of nest of microservices. And so you can use that both to gain a better understanding of how it works, and you can use that to attack places where there's latency or errors. And then once you figure out the service that's slow, you can use things like Profiler or Debugger to go into the code for that particular service and find out either why it's slow or why it's causing problems.
Yeah, hi. What's the actual performance impact of these APM libraries?
Yeah, so the performance is essentially negligible. So for Profiler and Trace, there's a small memory impact. For Trace, also keep in mind that traces are generally sampled, so most customers trace about 1% of the requests. Tracing at a higher sampling rate can have a small impact on your application's performance.
Can you give me a number rather than small?
It depends what language you're using. So I think for Profiler, we use like 5 megabytes of RAM for most languages. It's really negligible for applications of any sufficient scale. For Debugger, there's no performance impact unless you're actually capturing a snapshot. So we have some pretty interesting techniques where we will slowly roll, when you set a snapshot in Debugger, we'll slowly roll it out across more and more instances of your app until one triggers, and then we get rid of them really quickly, with the goal of only having one instance of your app trigger on a snapshot at any time. That's because a snapshot does imbue a bit of latency.
Okay, thank you.
Maybe to add to that, if you can imagine, we're using that in Google in production, and Ben is somewhat sticky about us not wasting resources. So we have done everything we can to make sure that the impact will be so negligible that it wouldn't show up in Ben's reports.
Yeah, we used all 3 of these at Google across some of our, well, certainly with Trace, like all of our biggest services, and the same for Profiler. The performance impact is basically undetectable.
Like anytime we introduce an APM tool into our ecosystem, the first question that comes up in the meeting is like, what's the impact, right? How much?
Yeah, and so just to double click on that, one of the differences you might see is that all of our instrumentation is in process, so it's libraries you link to your app. We're using APIs that we expect to capture data. So we've gone and done the hard work to build integrations for like Trace, for example, for like gRPC and HTTP and everything else. And so we use those APIs, which generally doesn't have a massive performance impact. I know that some vendors do like some amount of monkey patching. They'll have like an agent that goes and injects itself into the JVM and changes things around. For those, the performance impact is much harder to define.
Thank you.
Yeah, I think that's a fair statement. I mean, one of my jobs is looking after the utilization of Google's fleet, and so even a very small percentage multiplied by a very, very large number is still, millions and millions of dollars. And consistently so far, not only has the statement been true that it doesn't even show up in our metrics of, the top 20 wasters of resources, but also as a practical matter, suppose that for the sake of argument, this thing consumes 0.3% of CPU on the systems that you run it on, but, as a result of running it, you every month discover a bug that was using 1% to 2% extra CPU. Pay the tax, right? So as a practical matter, we've always seen that we make so much more progress with these sorts of tools running than what we pay for them, which is a very, very small amount, that it just is not a topic that crops up because the ROI is so very clearly positive.
You get a book.
Give them a book, yes.
Hi, I'm a data scientist, and as part of our application development, we have to train machine learning models and deploy that. So as our budget is a little bit more complicated. Can you comment on how SRE principle apply to this kind of work as well?
Sure.
Are there any important differences?
Yeah. So the philosophy around error budgets is, in fact, very much that different services have different availability requirements, right? And ultimately, you are trading off availability versus feature velocity. And so oftentimes for data scientists, right, if your system doesn't work 3% of the time, fine, right? Because if that allows you to have an extremely rapid experiment, launch and iterate, you'll make much, much more progress just sitting out those 3% than you would if the system was 4 nines available, but there was a 2-day lengthy process of getting experiments vetted and blah, 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 blah. So with SRE, one of the key ideas is we don't specify for you what the availability has to be, right? It is a function of the service that you're running, and it is very much a trade-off between what's enough availability to keep all your users happy and enough feature velocity to make sure that you're getting your business needs accomplished. And for data scientists, we have no problem at all. In fact, I think this is not material, non-public information. So, we're obviously generating, working on new generations of machine learning accelerators and so on inside of Google. And one of the classic questions that pops up when you have the first batch of them is, should we put them into production? Should we let people use them? And 100% of the time, the data scientist team says, yes, right, we're fine if it only works 90% of the time because we want all the performance and all the new model sizes that we can run on this thing. Totally fine, right? You set the SLO to be 90%, everybody's happy. Yeah.
I guess the existence of these 2 books is part of the answer already for my question, but is Google planning to offer now or in the future SRE training or certification?
I'm almost tempted to call, yes, exactly. So I'll save Dave the embarrassment. The answer is yes, and in fact, we already have a team called Customer Reliability Engineering, which is populated pretty much exclusively by ex-SREs, whose job it is to go and work with our customers and both do SRE training and to help them implement a number of the sort of SRE practices into their environment. And it has been, success disaster is an overused term these days, but let's just say there's a long waiting list for CRE engagement, and so we've had maybe we should find a more scalable way of offering this set of services to folks. And so, in addition to the books, we're now actually looking at various training mechanisms. We want to have something that will work in the real world. Like, I'd like people to actually be able to apply the principles that are useful to them and their business and get good results out of them. So it's not a trivial exercise, but it is very much something that's in process.
And I want to add to that, Dave and Liz, Dave runs our CRE, and Liz is represent SRE in many places, are both here and would love to talk to you. We're working with a lot of partners to scale, because it's important for us that we can meet that demand. We welcome anybody that want to engage with us and help. It's important to us.
All right, so with that, the clock hidden below the orchestra section is telling me that we're out of time. So thank you all for the questions. The judges are going to confer briefly and figure out who gets the set of spectacles. But thank you all both for attending and for some good questions. If you can...
Welcome back to Next 18. I'm Redo Meyer.
And I'm Stephanie Wong. Sam O'Keefe, head of Google Cloud for Startups, joins us now to help recap the developer keynote made here together. Thanks so much for being here, Sam.
Thanks for having me.
So I kind of want to start by talking about all of the cool live demos that we saw during the keynote today. We had everything from Kubernetes, Firebase, automated canary analysis. Can you tell us which one was one of your favorites?
Yeah, well, first I want to pause and say, it's great that we had live demos, right? This is the developer keynote. We wanted to really make this feel more like a meetup than you're in this auditorium with 6,000 other people, which of course we were. So I'm just really thrilled that we brought that element in. For me, getting to see Kelsey Hightower do a demo was amazing. He is so well known in the Kubernetes community, but one of the things I really liked that he worked Istio into his demo. Earlier this week, we announced Istio 1.0. It's been around for a while. It's growing really rapidly, but a lot of the developers in the audience may not have been hands-on yet. So having Kelsey show them how simple that was to integrate, to customize, hopefully makes it a little accessible and people start to try it out.
Yeah, absolutely. Well, one of the cool demos that we saw was the build demo.
Yes.
How do you think that's going to impact developers in their daily work, on a day-to-day basis?
Yeah, hopefully in a big way. Melody talked a lot about DevOps, and Cloud Build kind of completes the DevOps triumvirate, as I like to think about it, how Google thinks about it, which is your cloud source repos, Stackdriver, and now we have Cloud Build. And a lot of our users were already doing some type of CI/CD solution, usually another service provider. But it just makes a lot of sense for Google to offer this. It's a part of their day-to-day work. And so hopefully it's all about reducing developer toil. That's our real goal. So hopefully it accomplishes that.
Yeah, I feel like the theme that we keep hearing about is kind of integrating our technology into what our users are already using and kind of bringing the cloud to them.
Yeah.
And it's another topic that I hear a lot about during this keynote is machine learning.
Yep.
That seems to be a very huge topic in a lot of the talks here. Can you tell us a bit about what keynote main takeaway for ML stood out to you?
Yeah, well, I think you hit it right on the head. I mean, Cloud Build, we didn't even talk about. It integrates with GitLab, GitHub, Bitbucket, right? It's meeting the developers where they are. So ML AI is no different. You heard Fei-Fei Li talks a lot about democratizing AI. And what we're offering at Cloud is really a suite of products depending on what your needs are, from the AI APIs to AutoML to managed machine learning engine to actually just TensorFlow, and you can take it and do whatever you want. So we're trying to give our developers that flexibility to meet their needs, and I think that's great. Hopefully it makes it accessible, inclusive. We want everyone to be able to use this technology.
Absolutely.
Yeah.
Totally. And now I know you're particularly passionate about startups. We saw a couple of them. We saw a couple of them on stage this morning. What are some other startups which we didn't get a chance to see that you're particularly excited about?
Yeah, there are a lot. We actually here at Next, we have a whole separate kind of lounge where we have content every single day with different CTOs and founders sharing how they're building on GCP. You also saw in Adam's opening video a bunch of startups doing amazing things. One of my favorites is Portal Telemedicina, based out of Brazil. They're offering remote telemedicine and using the cloud to do that. Healthcare seems to be a big theme in startups and ML. So in our lounge, we had Picnic Health and Cardiogram, both that are structuring data using machine learning and then trying to do predictive diagnostics. So that's just a couple. I could go on, but I don't know how much time we have.
No, thank you for sharing those.
Yeah.
And thank you so much for your time this morning. It's been a real pleasure.
Absolutely. Thanks for having me, and thanks for watching.
Of course.
Thank you.
All right, now let's go out to the showcase zone for a final look at some product demos.
Hi, I'm Natalie, and we are in the global change space. And today I'm joined here by Chris. Chris, tell us what we're doing to make sure that everything that we do at Google is sustainable.
Yeah, thanks for asking. So one of the things I really appreciate about Google is we have these bold mission statements, right? Organize the world's information and make it universally accessible to everyone and useful. So we also have a mission statement when it comes to the environment, and that's to enable everyone from governments and businesses to individual users or communities to use our Google technology to make the world a more sustainable place. And when you think about how the cloud is influencing everything that we do, cloud technology plays a huge part in helping all of our customers, all of our users to make the world a more sustainable place.
So speaking of cloud technology, obviously to enable that cloud technology behind that sits very large data centers. Can you tell us what we're doing in the data center space around sustainability?
Yeah, absolutely. So the first part is making sure you build the most efficient data centers in the world. And Google does a lot when it comes to efficiency in our data centers. They're actually, across the fleet, we're about 50% more efficient than typical data centers in using energy to provide this cloud computing power. Google is actually the largest corporate purchaser of renewable energy in the world. So every single watt that we use in our operations is actually offset by renewable energy that we purchase, because we match renewable energy to the energy that we use. And what this means for our cloud customers is if you move your compute or your storage or your applications to Google Cloud, the net carbon impact of your usage is actually zero. Because we are offsetting all of your usage with the renewable energy that we buy.
Wow, that's really interesting.
Yeah, it's super cool. It's one way that a lot of customers who might not have access to purchase this renewable energy themselves, if they move it to Google Cloud, we actually offset their energy for them. We actually refurbish 36% of the servers that we deploy in our data centers. And we use refurbished components in 22% of those servers that we use. So we're trying to ensure that the use of virgin raw materials is as little as possible when we build our data centers. Environment.google is a fantastic resource. It talks about all of our environmental efforts, from our data centers to how we build our offices for our employees. And then there's also a bunch of information about how we actually build data centers that hangs off the Google Cloud pages.
Now I'm joined here with Karen, and we are going to be speaking about how Google is partnering with social organisations together to build really innovative solutions, just like Global Fishing Watch that we have here. Can you tell us a little bit about this program?
Sure, absolutely. So this is an application called Global Fishing Watch, and together with the nonprofits Oceana and SkyTruth, we helped develop this application. What's amazing about this is that it actually takes GPS locations of fishing vessels all over the world, and it uses Google's machine learning engine to detect the patterns of the GPS tracks to understand which ones are fishing and which ones are not. With that information, then governments can better monitor and sustainably manage their fisheries, and they can also detect illegal fishing.
Can you tell us about this solution?
That's right. So this is called Map of Life. Yale University actually was already mapping different species range habitats.
Okay.
What is unique about this is they were able to use Google Cloud and Google Earth Engine running on Google Cloud to better detect where the species habitats were. For example, they get a more accurate picture of topography, a more accurate picture of land cover and land use of different vegetation on the ground with satellite imagery and geographic data. And so what's really interesting about this demo is that you're able to go in and see a specific species, say for example, the eastern gorilla, select it, and actually see the very fine-grained habitat that's now Map of Life makes available on the web.
That's quite interesting. And is that being created using some kind of vision capability, or how does this work?
It's actually being created using geospatial analysis, which is offered through the Google Earth Engine platform on Google Cloud. So it basically takes all this geographic data, crunches it on Google Cloud in a parallelized way so that a lot of data can be analyzed in a very short amount of time.
Yeah. So next we have?
This is a project that Google worked with the Rainforest Network to build Rainforest Connection. And basically what this is, they used acoustic sensors and machine learning to understand sounds in the rainforest. So they were able to put solar panels as well as acoustic sensors in the forest canopy, and whenever they heard a chainsaw, an alert would happen, and you'd be able to see an SMS alert go directly to the cell phone nearby so that they could go and immediately stop illegal deforestation from happening. And what's remarkable about this is that the TensorFlow algorithm is working on these devices in the forest, and so you're not having to necessarily crunch a lot of data, send a lot of data up to the cloud. That only happens if the alert is actually deforestation.
And that TensorFlow on device was something that we just actually launched not so long ago.
Fantastic.
So great to see.
Yep.
Great to see it being used for a really great cause. So we've got one more left, and that's Project Air.
Yeah, so Project AirView is an effort that we've been working with two organizations called Environmental Defense Fund and ACLIMA. And we have been deploying air quality devices on Street View cars around California, a little bit in Texas, and starting soon in Europe. And so basically what we've been trying to do is map the world's air quality at a very hyper-local scale so that neighborhoods and cities can actually implement changes to improve the air and to lower air pollution. And so what this demo is showing is that if you have this kind of big data, not only streaming up from many different devices using Google Cloud's IoT Core technology, as well as Google BigQuery to analyze the data very quickly, you're able to see different areas of high air pollution, and you're able to see and answer questions about why that may be.
I think it's really interesting to see, how we're taking a solution like our Street View cars that are already kind of doing a job on their own to kind of map the world, but being able to embed this technology on top and extract even more data.
That's right. Yeah, all of these projects are all about leveraging Google technology,
Yes.
and Street View is one of those. We already are out there driving and collecting 360 imagery, and now we're actually able to turn those into an environmental sensing platform.
We're here in the final story on the global change space, and we're joined by Elise, and Elise is going to tell us about some of the non-for-profit success stories.
Yes, absolutely. So welcome to the space.
Thank you.
Here we actually have some nonprofit organizations that have been working with us for some time to actually help craft a new program that we're announcing today, which is called Data Solutions for Change. So what we're looking to do is actually help these nonprofit organizations access our big data solutions and machine learning solutions so as to achieve their missions at scale. With these nonprofit organizations that we have featured here today, they actually helped to pilot the program. So they received some of the benefits, which included a cloud credit grant and hands-on support along with self-training resources. And in working with them, that's how we essentially came to finalize those benefits and offer what we're offering nonprofits today, which again is a need-based cloud credit grant of up to $30,000 for the duration of the 6-month grant period, self-training resources through Quick Labs, and hands-on support through Google Cloud customer support at the development level. Data Solutions for Change is totally new. It's something that we just came out with today and are welcoming nonprofits to apply starting today.
Yes,
and
very exciting.
There's another exciting initiative that we're announcing with the goal of not only supporting nonprofit organizations, but also welcoming the next generation of data scientists, analysts, designers. It's a data storytelling contest called Visualize 2030, which is really exciting because we are partnering with the World Bank, the United Nations Foundation, and the Global Partnership for Sustainable Development Data. And we're asking students at the college and graduate level to essentially tell a data story around at least 2 of the Sustainable Development Goals that were established by the UN. And as a bit of background, the Sustainable Development Goals, they number 17, and they range from anything around preserving biodiversity to ending poverty.
Amazing. It sounds almost like a bit of a hackathon that we're kind of bringing a call out to anyone, working in these social organizations who have really great skills in big data and analytics to come up with a solution to some of these, amazing, impactful stories.
Yeah, and specifically we're looking to tap into, students, the brilliant minds of students, because it's crucial to recognize that Visualize 2030, it takes its name from the 2030 agenda. And that next generation is critical in order to drive the kind of change that we need to see in order to achieve that agenda by 2030. And it's also worth noting that we're asking students to use Data Studio. Data Studio, which is our free visualization tool that actually helps anyone who can access the aforementioned tools go from structured data sets, go from BigQuery to visualization in seconds.
Thank you so much, Elise. Really enjoyed having you here and your time. Thank you so much.
Yeah, thank you for your time.
So Brian, tell us a little bit about what we're looking at here.
Sure. So this showcase is entitled Migrating the Monolith, and it's an interactive journey that takes you through the thought process of deconstructing a monolithic application like Java or .NET into a collection of microservices that you run in the cloud.
What are kind of the advantages of doing something like that?
Yeah, some of the big advantages, obviously, one would be agility. So rather than having a single stack architecture, now you've broken this into microservices so you could have smaller development teams working on each piece and they can update independently of one another. So that's one thing. Another thing would be in running in the cloud, you are infinitely scalable. So you can scale up or scale down and you can automate that. And there's a lot of cost savings because of the scale economies.
Sure. Are there any challenges that people come up with when they look at migrating from a monolith to microservices?
Yeah, there are different ways to think about migrating. One of them would be lift and shift. And so recently we acquired the company Velastrada, which makes VM to VM migration really easy with the tools that they've developed. Another way would be application modernization or re-architecture, and that's where you're breaking down something, and that can be difficult. We have our professional service offerings called Cloud Sprints to help migrate, how you think through domain-driven design in order to break down a monolith, and then having the right skill set to develop for those applications that are going to be microservices.
Gotcha. So people who are here at the conference can come play around with the application, but where do people go if they want to learn more?
So we've got some great white papers. So if you go to cloud.google.com/whitepapers, there's a series of 4 white papers. They cover everything from lift and shift to migrating the monolith to containerization of an application.
Perfect. Well, thanks so much, Brian.
Yeah, my pleasure.
So James, retail banking is a very traditional industry. What is Google doing to transform it?
Yeah, that's absolutely right. It is a traditional industry, but there's been an intense focus on the consumer experience as of late, and part of Google Cloud's mission is to build new customer experiences and help our customers, help their customers find a new way to do business with them. And so one of the things we have here is a new retail banking experience, specifically around the mortgage experience and mortgage application. Now, if you ever bought a home, it's a very painful process, a lot of paperwork, a lot of finding times to meet with bankers and get mortgage estimates and those sorts of things. And so what we have here is a solution where you start on the home and it's integrating multiple parts of Google, the best of Google. We have Google Assistant, we have devices, and it's integrating all of those different pieces with other parts of our technology to create a seamless customer experience from the initial shopping for a mortgage all the way through to the application and the funding of the mortgage. It's really transforming the way consumers are shopping for mortgages and getting mortgages and everything they're thinking about how to interact with their bank.
So James, if our customers want to learn more about these solutions, where can they go?
They can go to the Google Cloud website under Solutions and find Financial Services. You can learn more about these types of solutions.
Excellent. Thank you very much.
Thank you.
Hi, I'm Mark. We're at the Internet of Things zone, or the IoT zone, showing off our cool stuff. I'm here with Preston. So Preston, tell us a little bit about what this demo shows.
So what we have here is essentially a mock piece of industrial equipment.
Okay.
And inside here are a number of sensors that we can't see the current readings for.
Okay.
What we have is this augmented reality app.
Yep.
What it's going to let us do is see inside, see the current sensor values. And if any kind of like alert condition were to develop in a sensor, like here we've got a pressure fault.
Right.
It's going to tell us we can actually turn that wheel to restore the pressure. So
All
go
right.
ahead and give
I'm
that
gonna
a
go
spin.
fix the pressure.
Yep. And then you'll see here the pressure is now restored.
Just like that.
Condition improved. So.
Perfect.
Yep.
Okay, so how does this demo actually work?
Well, let's go over, we're going to look at the kind of architecture of how Cloud Platform is used to build it over
Perfect.
here. So it all starts here with IoT Core. So each of these connections between devices is secured so that we're only accepting data from devices that are authorized by our users. And it starts not only with this one device, but you might have multiple devices. So up here we have a representation of multiple devices that are similar in the field. All of these devices connect in through IoT Core. This data is then funneled and delivered to Cloud PubSub by IoT Core broker services. Once it's in PubSub, that can handle sort of the distribution of multiple copies of the message to different downstream consumers and processors of the information. So in this architecture, we've got two different receivers of that data. One is Cloud Functions. Cloud Functions, you can do simple computation on individual messages. And then we also are using Cloud Dataflow to look at multiple messages over a window of time. We can do things like calculate the average of a temperature over a 5-minute window, that kind of thing. Once we've got that data processed, we can then put it into Firebase. Firebase is what will then handle the signaling of the final results out to the applications that users are actually interacting with.
Okay, so we kind of have a secure way to grab information from the devices, publish it out, transform it or take whatever steps we need to, and then finally put it back out to the applications that people are using to see that data.
Yeah, exactly that.
Perfect. So where can people go if they want to read a little bit more about this?
So if you go to cloud.google.com/IoT, you'll see more information about the services, but also partners and hardware kits that we've developed for people to get started with.
Perfect. Thanks so much, Preston.
All right, thank you.
Thanks to the Showcase team for all the cool product demos and installations you shared with us over the last 3 days.
And that's a wrap for us here at Next 18 in San Francisco. Thanks for joining us for a fun-filled week of all things cloud. To watch everything we've live streamed on Next On Air this week, visit our YouTube Google Cloud channel at youtube.com/Google Cloud. And be sure to check back on our next website, g.co/next18, in the coming week to see recordings of our breakout sessions.
Next 18 travels to Tokyo September 19th and 20th, and then to London October 10th and 11th. Make sure to register for those conferences if you're in the area.
And to stay up to date on Google Cloud products, news and events, and to contact our cloud team, sign up at g.co/next18/stay in the know.
Thanks so much for tuning in. We'll see you next year.